Welcome back to this new tutorial. We're going to learn how to create this web application using Kotlin Multiplatform. This is going to be a very beginner-friendly tutorial. We'll learn a lot of things throughout this tutorial. So we're going to learn how to fetch data from an API using Ktor client. Also, we're going to learn how to save data locally using Room database. Also, we're going to learn how to perform dependency injection using Coin library. Also, we're going to create this amazing UI, which also supports dark theme using Jetpack Compose. And above all, we will learn how to use MVVM clean architecture to structure application. So guys, let's code together and build this amazing application. Without any further ado, let's get started. Okay guys, so you can easily grab the starter code inside the GitHub repository. So the link is going to be provided in the description box below so that you can get started. So you can create a brand new project from Kotlin Multiplatform wizard, but I have added several things that are going to help you get started. So for example, when you go directly here inside the build.redo file and navigate to our Compose module app, so if you don't see this view, you can easily just change it here directly project and Android. So you can select this Android for now because we want to investigate here build scripts which we have. So you can see here we have several things which I have changed, and if you want to see the versions that I have added are going to be placed inside here. So you can see we have the Kotlin time. We're going to use material 3 window size class so that we can use it to display our views correctly. Then if you want to use navigation for Compose, basically you can use this one. Kotlin serialization for serializing our JSON data. Then we're going to use Coin, and this one is going to be our dependency injection library. Also, we're going to use Ktor. This Ktor is going to be used for communicating to our API service. Then we have Coil 3 that is going to help us to actually fetch images at real time. So for example, we're going to supply it with URLs, then it's going to help us fetch the data from this particular image place. Also, we have the KSP that are going to be used for Kotlin processing. These are going to be used with Loom databases. Also, we have here SQLite version, so we're going to use 2.50 alpha. This one is going to be for our database. Also, we're going to use Room database as our higher level framework to communicate to SQLite. So there are several things here. You can see we have added these, which are compose navigation, the way which we want to define the dependencies. And here we have the Coin, and here we have the Ktor, all the libraries which are going to be required. Also, we have the Coil, as we have said before. Then we have the Room compiler, and also the material 3 and the bundles which we're going to use. So these one are going to be different in different platforms. And after that, then we have here the plugins. Basically, here you can see we are specifying the KSP and the Room plugins. Then we are creating here a bundle for easy access inside here our build Gradle files. So you can see inside here we have added this Kotlin serialization, the KSP and the Room as our plugin. Then inside our Android dependencies, we are going to define the Coin. So Coin works differently from Android and other operating systems. Also, we're going to use Coin for Compose. And also here we are going to use for Ktor client, we're going to use OKHTTP as our client to communicate. And inside here, our common source sets, this one are going to be available across all source sets. So nothing platform specific here. So basically you can see we are using lifecycle view model, lifecycle runtimes, the material 3 window size class, the Kotlin date time, and other things we have here, the compose navigation, serialization, room runtime, and the bundles, which we're going to have here. Another case, we are adding this API basically to create our Coin, which is just the core library for Coin dependency injection that is going to be available inside our common main source set. And also we are adding Ktor and Coil so that we can easily access it inside our Coin source sets. Okay, so another thing here which we have is our desktop main. So you can see here we have our desktop as our current OS. So we're going to add this compose depending on different OSs. So if you're going to learn it inside Mac OS, then it's going to select that, or we are learning inside the Linux, then it's going to select that OS. Then we're going to use Kotlin coroutines. So Kotlin coroutines works differently from different platforms. So here, for example, in order to access Kotlin coroutines, you have to add this swing. This one is going to provide us with the support of Kotlin coroutines inside our desktop environment. And also our desktop environments are going to use OK HTTP to communicate for these cases. And that is for Windows and also Linux operating systems. But if we want to use iOS or Mac OS, basically we're going to use these native main.dependencies. And basically here we're going to use a different client. So for example, here we're going to use Ktor client Darwin, which is different from OK HTTP. So these are platforms specific things, but nothing to worry about. Another case which we have added here is the room database. So you can see we are going to specify the schema directory where our project or our database is going to be stored. So for a case, we are going to select project directory /schemas in order to store our databases. Another case, we are going to add the dependencies. So this is for KSP. So we are going to add this in order room to generate those files. So these are going to be different from different platforms. So you can see we are going to use KSP desktop, for Android, for iOS simulators, for iOS, and also KSP iOS. So things about iOS, you're going to add like this one, and KSP Android and desktop. You can use this for Windows and Linux operating systems. Other than that, everything here is basically the same as how you get it from the Kotlin multi-platform wizard. Okay, so besides here, build.creator files, I have added several things. So let's go changing here inside our Android to project source set so that we can view. So you can open up here our compose. Let's directly go to our common main source set. And directly here, you can see we have several things. So one thing I have added is this util folder here, which basically contains several things. So you can see we have here the flag URL. These are just the URL and endpoints which we can hit with our API so that we can get our data. So this one, we are going to use OpenMeteo in order to fetch the data. And also they provide other things to get geolocations. So which locations we are going to use this one, same to OpenMeteo. And also these are the endpoint which you are going to use, which is forecast, and also to search. For search is for geocoding basically. Then these one are just parameters which we're going to use them. So, and here I have added a type alias, which is just a substitute for the string so that we can easily identify it. Hey, this is a URL instead of just passing up a string directly. Okay, so inside here, I have added also the utils folder. So inside here, utils folder, I have added, for example, the directions, which are just going to be the directions of the wind. Then we can use this to format our directions, which we're going to have. And then we have different ways of formatting our date. So we are going to use Kotlin date to actually serialize our date to what we are going to know. So we're going to have here a pattern, then we're going to receive this and convert it to instant. Then we're going to perform a formatting, a basic formatting this in order to get our type of format that we desire. Okay, so typing this one by one is going to be tiresome. So basically what we're going to have is our API is going to return a code of a particular weather information. So we are going to create a custom class that is called weather info item. Then we are going to basically map that to a specific type of view. So we are going to have here, for example, a clear sky icon for this clear sky. And then we are going to have several types of codes that are going to be actually changed. So you can get this when you download the GitHub starter project. So the link is provided in the description box below. Okay, so this is the API which we're going to use. So to directly lead to this website, you can just go to this website here, openmoteo.com. And this one is free to use for your own non-commercial purposes. So if you want to use it in a commercial purpose, basically you can just try to use their plans. So you can click here features in order to see all the features which are available here. So they have a lot of information with these REST APIs here. So for a case, our first items or feature which we want to create is getting the geolocations, basically the location which we can use to fetch the data. And here we have the geocoding API. So we can select this, and basically here we can search for any type of city. So you can see we have name, language, and number of results that are going to be returned. And here there is format. So For our case, we're just going to stick with JSON as our response. So you can see here the preview of the URL is going to return the data similar to this one here. So for case, we have this Open API URL. So we have this URL here. You can see directly they have given us. So we can click open in new tab, and this one is going to open up to a new tab, and we have here our result. So you can see it's going to return here a number of items. So for case, we can just press Ctrl A or Command A to copy this, and press Ctrl C or Command C to copy. Now we can go back to Android Studio in order to actually fix our data and start to use it. Okay, so we are back inside here Android Studio. So the first case, we want to create this data, and basically we can create here a folder structure for our geolocation. So the first case, let's create here a package. Let's call this geolocation. Then let's create another package here. Inside here, we can call this remote. And inside our remote package here, we can create another package. Let's call this models for models. Now let's create here a new Kotlin class or file, and basically we want to create this from JSON. So I have this simple extension that is going to help us for this case. If you don't have this extension here, you can easily just download it inside. You can go here to settings, for example. Let's go to settings, or directly go to plugins here. When you click, and you can see we have here plugins, and here you can search for JSON to Kotlin. Okay, so you can see here we have the JSON to Kotlin class. So basically I have already installed. That's why you can see it's showing me to update. So if not, you can just easily install it here. Like this one here, you can get this dedicated button. But for case, we're just going to click OK here. Okay, now after that, we can click here Command End in order to create a new package. So for case, we are going to select this. And inside here, we are going to paste the JSON data which we have copied from our REST API response. Now let's call this geolocation, and before we add anything here, you can click this advanced here in order to make the settings. So for case, you can keep this as well, and here non-nullable. You can select nullable in order to make them nullable, and the default initial values. So we want to init this with default values. For example, we can avoid the nullables. Another case is annotations. Here we are going to select Kotlin X serialization because we are using Kotlin serialization for serializing JSON to data classes. So it's going to help us to generate those files. So for case, let's call this geolocation DTO, standing for data transfer objects. Let's click generate here. So it's going to generate. We have two files, so let me add them. Okay. So after these files have been added, you can see we have here the geolocation, and here basically we have the generation time and the result. And you can see the other result here is we have, okay, so it's going to add a lot of data, and this one typing one by one is going to be cumbersome. So for a case, we can use this plugin in order to generate for us. Okay, so we have here a remote package. So the next case is we want to store this geolocation data inside our database. So we don't want to fetch every time for the geolocation. So if the user save it as a favorite, then we can keep it there. Next time we can easily access it. So here we can do easily to create this. So let's create here another package. Okay, so we can call this locals. Let's create here a new package also. Let's call this models. Okay, so inside here for our models, we can create now our Kotlin file. Okay, so we want to make this as our data class. So we can call here our geolocation. Okay, so we are going to create here our geolocation. So we want to pass in here several variables. So the first variable is the ID, name, country code, country ID, the latitude, longitude, time zone, and elevation. So these data are going to be saved inside here. So to tell that room database, hey, basically this one is going to be a data that is going to be stored inside our SQLite database. We have to tell, hey, this is going to be an entity. So we can call here entity, and you can give it a custom name. So for example, let's call this geolocation table, and Android Studio room database is going to understand this. And here basically we have to specify one key that is actually a primary key, and say, hey, we have here a primary key, and for a case we are going to set this as at primary as a primary key, and we can set here auto generated, and we can set this back to false. So we don't want this to be generated, and we are saving here to 1 because we want only to have a single item inside here. So if you want, you can create another table that is going to be favorite and create a relational database. But for this simple tutorial, we are not going to do this. So we want only to create here a single location that is going to have our item. That's why we are returning only a single item inside here. Okay, so here we have our geolocation, so you can see everything is looking perfectly. The next case which we want to do here is actually to create a data access object. So a data access object stands for DAO. We're going to use this in order to communicate to our SQLite database using Room database. So Room is going to sit as a top layer that is going to help us to orchestrate the communication between the database and our code. So this one is going to help us tremendously. So let's create here a new Kotlin class of file, and basically we're going to select the interface. And for a case, we are going to call this geolocation. Okay, so for our DAO here, we can annotate this to tell Room database to generate the implementation of this by using @DAO. So this one is going to tell, hey, you have to generate the necessary files. Okay, so inside here, we are going to perform several actions inside our SQLite database. So basically, we're going to use annotation to tell Room database what we want to perform. So for example, we have this suspend function that is called upset. So upset here is going to actually insert or update our database items which we have saved them. You can see inside here our parameter, we are passing a geolocation entity, and this geolocation entity must be annotated with @entity, otherwise Room is going to complain to us and throw a lot of errors. So for this case, we have to mark it as entity so that it can be saved. And telling here by using this upset here, it's going to either update or is going to insert a new record or update the existing record if it's going to have the same ID. So for this case, it's going to use the same function to actually insert and update. Then we're using here a transaction. This one is going to atomically insert or update. So basically, if we have, for example, we are inserting an item, then we are inserting again another item. So sometimes it's going to mess up with our Room database. So we want this to be executed atomically and avoid issues. And if there is any issues, for example, our item is not saved successfully, we want to roll back to the previous snapshot, which was the previous item. So not losing all of our progress and our data. So this one is going to help us for that. Now, another case here, we're using @query. This one is going to help us to write raw SQL query. For example, here you can see we are writing select, and we want to select everything from the geolocation table. So here we are selecting geolocation table. Then we can use, for example, here limiting or order by and do other things that we can use inside SQL or SQLite queries. So for this case, you can just call here at query, then provide your query that you want to perform. And here, basically, we are going to return a flow, and this is going to return the geolocation. So a flow is going to actually be a reactive stream that we can easily observe inside our UI. And you can look here, we are not using a suspend modifier, as here we're using a suspend because this one is going to actually take a lot of time when we want to fetch this, so we don't want to freeze our main UI. But however, here we are not using this because flow is actually called emission. So basically, we are not going to be emitting values if we do not start collecting it. If you don't know about flows, I have videos explaining about flows and coroutines in more detail. So for this case, flow are actually called, so no need here to pass as a suspend modifier when we want to execute. So when we collect, actually, we are going to call the suspend that is calling collect, and there we can use a coroutine scope to actually scope that. So if you want to learn more, you can check those videos inside my channel. Another case here, you can see we are providing another function that is called the clear geolocation, which is going to clear up our database. You can see we are passing here a custom query, delete everything from our geolocation table. So we are going to clear everything when we want. Also, we're using here a transaction to make it more atomically executed. Okay, so the next case which we want to actually construct here is actually a Room database. So we have to construct this in order to add the entities and other things in order to generate. So for this case, let's go inside here and actually create a new Kotlin class of file. Okay, so let's call this geolocation database. Okay, the first case, we're going to make this abstract, and this one is going to inherit from the Room database. Okay, so we have to tell room database, hey, this is going to be a database class. So we have to provide the annotation. So the first annotation here is a database. Then we can provide the entities. So inside here, all the entities, if you have other one, you can provide a comma and provide the other entity because we have only the first one. Then here you can specify the versions. So for example, at future, you want to change the entities, then you can bump up this version. Then you can provide a migration scheme that is going to help you to migrate from version 1 to version 2. So for a case, we are going to do that. Another case which we have to do is to provide a constructor. So basically, using room database, you have to say, hey, we are going to use a constructor in order to construct this, because we're going to use different type of constructors. If you're coming from Android, then this one is not specifically needed. But for multi-platform, we have to provide a constructor class that we are going to use. But for a case, we're going to create this class. For now, let's leave it as how it is. The next case, we want to provide the name of this particular database which we are going to create. So for a case, we can create here a constant variable. Let's call this db name. So this one is going to be the name of our database. Next, we can provide the function that is going to be used. So the DAO which we have, you can specify them here in order to access them. So for a case, we are going to call this geolocation DAO. And this one is going to return the geolocation DAO, which we have created. So now we have to set up the constructor. Let's look at how we can make this. Okay, so for this case, we have to construct here our constructor inside our local. So let's create a new file. Let's press Command N. And here, basically, let's create a new Kotlin class or file. And we are going to select an object in order to make the constructor. Okay, so this one is going to be called geolocation constructor. Okay, so this geolocation constructor is going to inherit basically from our room database constructor. So let's call this room database constructor, which is an interface. And basically here we are going to call our geolocation database, which we have created, which is basically the class that we have. So there is one function which we have to override. So let's press Control I in order to override this. And here we have the function which must be implemented. But for a case, we're not going to implement this. So the thing which we are going to do here is actually make this to be used by room database to generate the functions. So here we must make this as an expect. And you can see here we are getting an error that we miss declaration, but these are going to be generated by room when we are going to compile this. So we are not going to create the actual implementation of this particular. So if you know about the expect and actual, so when you declare expect here, it's going to expect from other modules. So you can look here at our modules. You can see we have here the Compose app. So you can see we have here the common main, then we have the Android main, and also we have the desktop and iOS main and other things. So this one is going to expect other modules to actually implement this. But for a case, we're going to leave this to room in order to generate those implementation for us. So for this case, we have to suppress this error which we are seeing here. So we can say, hey, this is going to be supposed to be generated by the compiler or room compiler. So here we can say no actual, and the error is going to go away. And here you can see Android Studio suggesting us this is still in beta. So basically you can look up at the track which you have. Okay, so here we have our geolocation constructor and everything is looking perfectly. So another case which I want to create here is actually the database factory, because we are going to have different implementation of how room database is going to be constructed if we are in Android, iOS, and desktop. So we have to provide the constructors for this case. So we can create a database factory that can be actually implemented from each particular module. So for this case, let's create here a new Kotlin class or file. And basically we can make this as a database factory. Okay, so this one is going to be an expect class. So basically it must be implemented from all of our data. So let's create here a fun, and this one function is going to be a create. Okay, so we want to construct here a room database builder, and this one is going to return our geolocation database. Okay, so we are getting here an error when you place option return or alt insert. Basically here you can see we have add missing actual declarations. So we're going to click this, and we want to add for desktop, Android, and also native. This one is going to create for all native which we have inside our application. So for this case, let's click OK. So it's going to update the index and actually add these files. Okay, so when you look here inside our, so now we are inside our common. So you can see, for example, inside here our desktop and inside here our Android, you can see we have a geolocation. And inside our desktop is actually not generated. So we have to create this. And from native, you can see we have here geolocation that is going to be applied also to our iOS. So you can see iOS doesn't have this. So basically here we can construct it. I think the Android Studio generation did not work inside here. So we have to make the folder structure similar to how it is. So we can just copy this. You can see how it is. It is geolocation, then locals. So let's do this for also our desktop. So I think our desktop factory is actually here, but it's not appearing inside here, our desktop main. Okay, no problem. Let's deal with our actual first here. Okay, so here we have several things. You can see we have database factory for Android and here for native. So we want to deal first with the desktop. So inside here, what we are going to do, I'm going to add this data here, which we are going to use. So for example, we are going to get the OS name. So this function here is going to help us to get the OS name. And basically by using system.getProperty name and call os.name, that is going to return the OS name. Then we want to get the user home. So we can get here user home. And after that, we want to create an app directory. This one is going to be a directory where we are going to save our data. And for this case, it's going to be different if it's for Windows and Mac, and else if, for example, in Linux or Chrome OS. So basically we can use differently. So for this case, we are creating a system, and basically we want to get the app data folder that we can make it as a forecastly. So for our case, we want to create this file here. And after that, if we are inside Mac OS, we can use this library here in order to save our application data. And after that, as we have said, if we are in Linux, then we can just save this to local/share forecastly, and our data is going to be there, our database where it's going to be located. If you want to save it differently, you can just use it differently for that case. And here we are checking if the database actually exists, then we can skip creating it. If it does not exist, then we can create that directory if this is going to be the first time that we are going to install or create that particular file there. Now, after that, we are going to create a database file that is going to be a file, and with Kotlin, we can just call here file and pass in here the app directory and the name of the file that we are going to be using. So for our case is the database. You can see we are using here geolocation database.db name. That is the name which we have specified inside our the database class. Then we can return a database builder in order to build here. So this one is going to be for our desktop. Okay, so next let's go for Android. Okay, so here we want to deal with Android. So for our Android here, we want to provide a context first in order to construct this. So for this case, we want to create a private variable and call this context. So this one is going to be injected using Coin. So they are going to be differently when we inject them in our application. So for this case, I'm going to add this data inside here. Okay, so what we want to do here is actually we are going to get the app context. So we can use the context that we have provided here and get the application context. Now, using the application context, we can get the database path, because for Android, the database path is actually stored inside the Android system folders. So we can get it by using the context get database path and pass in the name of the location which we want to call the database name. So here we are going to get back the database file. And for that case, we can construct our Room database builder by providing here the context and the name of that particular file. So for example, we want to call this database absolute path in order to get the path of that particular folder which we want. So that was for Android. Let's go now for native, if we have anything related to native. Okay, so the first case here which we want to do is actually to get the document directly. So for our native, it's going to be differently. So we're going to use the NS file manager. So for this case, we want to get the default manager and get the URL for directory. Then the next case here, what we want to do is actually get the database path. So for example, here we're going to get our document directory. Then we can embed here our name. That is actually the database which we want to save it. So we're going to get here the path from, for example, iOS, where it's going to be saved, and other places. Then we can pass in here the geolocation database name to the name that we have saved there. Then we can return the constructor of the database builder, and here we are just passing the name. There is no any context that is going to be required. So for this case, we have everything that we require for our application to function in Android and other operating systems. Okay, so basically here our document directory function is going to give us the document directory where we can use to save it. So you can see here we are using ns file manager.default manager and get URL for directory. So this one is going to use iOS native file management system to get the URL of the document directory. Then here we're using the ns directory. So the ns directory here is going to specify the document directory where we are supposed to save the documents. And here basically domain, and basically we are going to restrict the search to the user's domain. That is going to be this one here. And appropriate for URL, here we are making it to be false because this is not going to be a URL. And here if the document does not exist, we are setting back to false in order not to create. So we know that this file is going to be there because the iOS is going to be installing different type of applications, not just our application. Then here errors, if there is any error during creating this, when they are happening, we can handle them here, but for simplicity, let's just keep this null. And here we are requiring this not to be null. So if there is anything, we can crash our application so that we can look at what is the problem before we proceed, because we can get a document directory that is not actually nullable. So for this case, then we can use here our document directory, and then we can pass in here our geolocation database and actually pass in the database name, and then we can construct our room database. Okay, so for this case, let's go back inside our geolocation database, because here we did not pass in here the constructed by, and basically we have already created our constructor. So here we can call our geolocation constructor and basically make the reference to that particular class. So basically now room database is going to be generating. So for this case, we have our database here, and we can click here make project in order to make everything so that we can see, hey, we don't have any errors before we add more codes inside here. Okay, so you can see here we have this error, and this error actually is showing us compilation errors. You can see common compilation backend. So it's saying that we have to report this as an issue that has occurred, but mainly I have seen this is occurring because of an actual implementation. So when you investigate here, you can see Android Studio actually failed to generate these for our desktop. So when you look here, for example, inside the Android main, you can see we have this folder geolocation that was supposed also to be created for our desktop main, but eventually Android Studio did not create this. So I think this is the bug in Android Studio when creating this actual implementation. So let's go directly here. You can see also we have an error that is actually missing actual declaration. So for a case, let's set up for our desktop main. You can see the desktop main actually is missing this. Let's click OK. Still, it's not generating inside here our desktop main. Okay, so you can see here we have our database that is actually generated. But when you inspect here, you can see this file is actually saved inside the generated. So you can see here we have compose build generated KSP desktop main. So these are going to be stored inside the generated and not inside here our desktop main. And basically whenever we build, that file is going to be deleted and create other things, which actually we cannot manage here. So for a case, we have to create this manually. I think there is a bug here. For example, if you validate cache and actually restart Android Studio, then it's going to give you everything as how it is. Okay, so for a case, let's just close that. And what we want to do here is to create the database factory for our case. And here, let's create a new package. So here we can create our geolocation. So you have to match like this. You can see here we have inside the forecast tree, we have geolocation. Then we can create our local. Okay, so locals. Then we can create here another function. Okay, Now we have to name it database. Okay, so inside here, we are going to add our database factory method. Okay, so it is saying that we are performing the declaration, but whenever we clean our project, that which was created by Android Studio, it's going to actually be lost because here we have our database factory, so we can create our database factory. And now let's go to our build and let's clean here our project. Okay, so you see here our database factory now. That file was lost. There is no any error for redeclaration. Now let's try to rebuild again. Now that error is not going to pop up again because it's going to be lost. Okay, so our build.creator file is actually completed and took a while, 35 minutes. And actually everything now is completed here and we don't have any errors. We are good to go and proceed to build our application. So the next case which I want to set up here is our dependency injection, because we are going to have different implementation depending on the platform specifically. So we can set up this once and for all so that we can just use it. Okay, so the first aspect which we want to do here is to create a DI package inside here focused inside our common. Let's go inside our common source set. Okay, so inside here, let's create a new package and let's call this DI. Okay, so inside here, we're going to create our modules package. Okay, so I want this to be a file. Okay, so the first case here, what we want to do is actually to declare a platform specific modules. So let's make this expect. And this one is going to return us with a module. And we're going to inherit from a module class. Okay, so we're going to implement the actual aspect of this. So for a case, let's create here our shared module. So for shared module here, it's going to be used inside here. So we can create a brand new module. Okay, so here we can start everything. So for example, if we want to create HTTP clients and other things, we can do it here. So for example, we can declare here our database. So we can use a single in order to declare that as a singleton option. So for example, we can specify here get in order to provide the functions which we want to be created. So here we can specify the qualifiers that are required for a case. So for example, we want to call this database factory that is going to be produced inside here. And what we want to do is to call create in order to create this. Then we can set the drivers. So let's call here the bundled SQLite driver, which we are going to get here. And after that, we can call .build in order to build. Okay, so there are platform specific things, for example, in providing the database and also the HTTP clients. So we can do this inside platform specific here. So let's place here option insert, and we want to add missing actual declarations here. Okay, so let's select for desktop. Let's select for Android main and also native main. So you can see here the folder destination. Okay, let's click OK. Okay, so similarly here, it's not creating the modules for actually desktop. Okay, so when we go here for, you can see we don't have the DI package inside here. When we come to native, you can see we have the modules here and we have the expect function. So what I'm going to do is let's copy this, press Command C. Let's paste it here to avoid other things. For our DI here, let's rename this. So we can rename the, instead of native, let's call this desktop. Okay, so you can see we have conflicting declaration, but I think let's go inside here, build, clean our project. I think everything is going to work perfectly. Okay, so now we want to set up the platform. Now we are going to use the modules for desktop. And here basically we can open up for modules. And for example, here we can create here something like HTTP client engine, so that whenever we call this inside a desktop environment, so let's call this HTTP client engine. Now for our platform module here, it's going to be created. So basically we're using a platform modules and HTTP client, and here we are returning OK HTTP. Okay, let's go for Android here. Okay, so another options which we can actually create here is, so here we want to pass in for database factory. So whenever we create our database, basically we can provide this. So you can see here for our case, this database factory is called inside here, and we don't have to pass anything. For our Android here, basically let's create our module. Similarly, let's pass in here the HTTP client engine. Let's create. Okay, so we're creating here our HTTP. Another case, we want to provide our database factory. So let's call here database factory. And here we are supposed to pass in the Android application. So we can grab it easily by calling here Android application. So this one is going to be given us by the Android scope by using the modules inside here. So because we are using this specifically for Android. Now let's finish up with macOS and native operations here. Okay, so here we can pass in a singleton. Oh, sorry, we have to create a module first. Okay, so similarly here we have to pass in the HTTP client engine, and instead of using the engine of HTTP, for this case we are going to use the Darwin, which is basically used for Mac OS, and here we can create it. And similarly here we can create our database factory. Okay, so whenever we have the implementation for our database, then this is going to be provided. So now we have here for our database, and we have our modules. The next case, we have to kickstart our initialization of our dependency injection. So Coin has to be initialized. So we have to create here an init function that can be called whenever we want to initialize Coin to start to provide it. So inside here, our database, let's create a new Kotlin class or file. Let's call this initialize coin. And basically here, let's create a simple function. Okay, so if we want to pass in here customized coin app declarations, so this is the place when we are going to pass it here. And by default, we can make this to be null. So we are not required to pass that function or that parameter. So here we can call start coin. And this is the function that is going to kickstart the generations of that particular items. So inside here, we can set up the config and actually invoke it here. Okay, so we have to pass in here the scope. So we can call this. So actually the coin declaration here, you can see is actually a type alias. You can see that it is a coin that is actually a lambda function that returns a unit. So that's why we can call invoke and actually call this, because that is just a type alias inside the coin library. Another case, we have to specify the number of modules which we have. If we have 10 to 20, then we can actually declare them here. So we have the shared modules for first, and also we have the platform modules that are going to be specifically from different modules. Okay, so we are supposed here to call this initialize coin, and basically this function should be executed from different platform depending on how it starts. So different platforms has different ways of starting coin. So we have to deal with this. So basically, let's go directly and start here for Android. And for Android here, we can use an application class to directly initialize coin. So if you're familiar with Dagger Hilt, also we use this action to actually kickstart the generations of the modules or the containers that are going to be providing the dependencies. So similarly, we can use Coin for that case. So let's create here a new Kotlin class, and let's call this, for example, forecast-tree app. Okay, so this one is going to inherit from the application class, that is an Android application class. Then we can override here at our main function on create. So that is just on create. Okay, so inside this overridden function, we can call init coin. Okay, so the problem here which I have seen is that I have added this inside here, our desktop main, the initialization. So we have to press Ctrl X. This is not supposed to be here. So this directly is supposed to be inside here, our forecast tree, inside our common main source set. So for this case, let's paste it here. Let's refactor this. Okay, so now I think it should be available inside here. Okay, so you can see we can import this function here. directly. Okay, so make sure that you are keeping this inside the common source set and not in these different source sets. Okay, let's collapse this so that they cannot confuse us. Okay, so now we are inside here Android, and for this case we want to initialize here our coin, and specifically here we have to pass in here the Android context, because you have seen that we are going to use context in order to create our forecast tree application. So we can pass in here this at forecast tree app in order to provide that context when we are creating room database. Okay, so after we initialize this, basically we have to go inside our Android manifest. And if you know Android manifest here, we have to register that class which we have created so that it can be picked up by the OS whenever it is running. So for this case, we have to call here the name, and Android Studio is suggesting to be this one. And while we are here, why not we set up some permission? So in Android, if we do not set this permission, then our application is going to crash. So we have to use a internet permission because we are going to fetch the data from the database. Okay, so I think that is going to solve our issues. And now for the part of Android, we have set up our coin. Now the next case is we have to initialize this inside our main, inside our desktop and other places. So let's go inside here, our desktop. Okay, so for our desktop here, we want to actually initialize this. So let's make this as a function. Okay, so let's keep it inside this way. And now we can call init coin. And we don't want to pass any type of configurations here because we are not inside. We don't want the context of this. And let's go to our native here in order to fix that issue. Also, sorry, let's go directly here to our iOS main. Now let's go to our main view controller here. Okay, so inside here, main view controller, we actually want to configure the dependency injection. So inside here, the Compose UI view controller, we have to set up the configurations. So you can call here configure. And this is the Lambda function. And here we can call init coin. Okay, so now here our geolocation is actually completed. So the next case which we want to do is we created this as our data. So inside here our geolocation, I want to format this. Let's create here a new package. I think we can format it here. Let's call this data. And these are supposed to go inside here. Okay, let's refactor these two packages to go to our data folder. Now the next case here, which we want to do is actually create another package. Let's call this domain. And inside here, let's create a new package. And also let's call this models. So here, let's create a data class. So for this class, we can call it geolocation. Okay, so this is the thing which we are going to have here. So we want geolocation for ID, name, country code, the flag URL, the country ID, latitude, longitude, time zone, and elevations. This way, we can easily separate the concerns of we don't want to use the entity inside our UI. So our domain is going to actually communicate to the data layer, and the domain layer is going to push the data to our UI layer or our presentation layer. So we don't want to have the direct communication from our UI directly to our data layer. So our UI doesn't have to know anything about the data layer. So this one is good for separations of concerns, and we can easily refactor our applications. Okay, so the next case here, which we want to do is to create our repository. So inside here on domain package, we have our models. Let's create a new package. And inside here, let's create an interface, and we can call this geolocation repository. Okay, so before here we start to create our geolocation repository, we want to have a response wrapper class that can help us to transform the data which we are receiving. So for example, if we are loading, we have to tell our UI, hey, we are loading. So you have to set this and update the UI according to that. So we can easily create a wrapper class that is going to help us for this case. Let's go inside here, our utils folder. And inside here, let's create a new Kotlin class of file. Okay, so inside here, you can use any type of wrapper class that you prefer. So for our case, we are going to go with this particular wrapper class. Okay, so this wrapper class here can seem a little bit complex, but nothing to worry about. Let's just collapse this. So you can see here we have two things that are going on here. So we have a sealed class, and basically this is just a response class. And here we are just actually inheriting the type T that is going to be the data that we receive. So this one can be used in any type of project and data type. That's why you're using here generic. So here, this is just for the data that we're going to receive. And here we have the error. So for example, if you have any type of errors that can be returned here. So you can see whenever we have the data, then we can just return here the response. And because we have no errors, so we can return nothing here on the part of the data. Another case, we have the error. And here we have nothing because when we have error, no data is going to be passed. And here we can pass in the actual errors. So inside here, you can see this is also a sealed class. And inside here, I have other errors that can be passed here. So you can see we have HTTP errors. So these errors can be 500 to 400 and everything that can be happening to a client. This one are going to be depending on the response that is going to be returned. So if we have, for example, 500 errors, then we can represent this to user and say, hey, we have a server problem for this case. In another case, if we have network errors and IO exceptions, connectivity issues, so basically we can use this network error and say, hey, we have a network error. And if we have serialization error, and this one is just default that we don't know what the error caused. So we can throw these default errors here. So we can react to this differently in our UI if we wish to. Then we have here the data object, and this one is actually loading. So you can see we don't have any response here. So we don't have any error. So we don't have data, and we don't have an error that is going to be inside a loading state. So that's why we are passing nothing and nothing here. Another function here, which you can see is like magic is happening here, but nothing. Basically here, what we want to do is to create a mapper function. So for example, when you have a response and this response contains a data in terms of entity, now we want to transform this response to a data that is going to use the domain model. So basically what we can easily do here is create this simple extension function. So this is going to extend our response class here. And you can see we are using here T, E, and R. So this way we have three issues here. So basically when we have a response that can be returned here, so we are going to return the type T and error. That is going to be the response which we have here, and we are creating a map. And map, here we can pass in the mapper that we want to transform. So here we are going to use T and return that R. So this one is going to be a new data type other than the T and E because we want to return another data type. So for a case, if we want to transform this from, for example, an entity directly to a response of our domain model, then we can easily do that here. Then this one is going to return a completely different one. So it's going to return a response of type R and E. So basically here we are checking. So if it is success, then we can map that function. And if we have any error, then we can propagate that error and send it because we don't have any mapping that should be made inside an error. So we can propagate it as how it is. And if when we are loading, then we have an error, then we can propagate as how loading it is. We don't want to perform any type of transformation here. So what we want to only perform transformation is when we have successfully get our data. So this is just a simple sealed class, and it's going to help us when we want to wrap our function. Okay, so another case here which I want to do is to create a API error response that we are going to receive here. So let's create here inside our utils, and we can call this API error response. Let's call this as a data class. Okay, so here we are going to have, for example, the error code so that we can use this inside our UI. So let's make this as a string. And here we can have the error message. So if we have the message here, so we can use the message to actually say, hey, we have something here. So now we can go back inside here, our geolocation, and actually make the changes which we want. Okay, so inside here, our geolocation repository, now we want to create functions that we can implement them inside our data class. Okay, so you can see here we have several things. So for example, we have the geolocation that is going to return us a flow of geolocation, and this can be nullable here. And also you can see we have the upset location. If we want to insert and update, we can pass in here the geolocation as how it is. Then we have the fetch geolocation. And here we want to use a query that is going to be a user typing there searching for a certain country. Then here we can return a response. So this is type flow, and you can see we have a response list of geolocations. So here we can have our data, and if we have any error, then we can pass in here the API error response class so that we can use it inside our UI to get the clear data. And here, if we want to clear geolocation and we want to clear, so everything here, we can use these functions here. I think they are self-explanatory. Okay, so you can see here we're using geolocation. So this is actually going to be the entity inside our database, inside our domain. But inside our database, we have geolocation entity. So we have to create a mapper that can map between these two data classes. And we can easily do this inside here, our data class. Let's go and create here a new package. And inside here, let's create a new interface and let's call this mapper. And here we have the domain, and also here we have the model. Okay, so here you can see we want to map from a domain entity to a, for example, to something else. So for example, here we want to map to domain, and we can call this map to domain or null. So this function here is going to map something from domain, or actually return null here, for example, because we are going to receive nullable items. So here we have a model, and this model is supposed to map it to domain. And if this is the case, then we have to send this back to null. So here it's going to return our domain, but this domain can either be nullable or not. Another case is we want to map now from domain entity directly to our data class entity. So for that case, we can map from domain now. So let's call this map from domain. And here actually we can pass in the domain and return here the model. As simple as that. Now we can create here the implementation for this. Let's call this geolocation mapper. And here we are going to inherit from our mapper class. So we have here a domain entity. So the domain is just the geolocation. And here we can pass in the geolocation entity. Okay, so here we want to map our domain. So basically we can use our model. Okay, so our model can be nullable. So we want to use run. So run is a scope function that is going to run the transformation which we are going to perform here. So here we're going to return our geolocation and pass in here the ID and other things. So that is easy as that. And let's import here our key. So this one is going to be the flag URL that we're going to get it here. So let's inspect this. When you press command click here, you can see we're going to pass in here the country code. So we're going to use this flagsapi.com. Then you can pass in here the country code in order to get that particular image. So we want to get this as here. Okay, so that's way we can transform everything. The next case is we want to transform this. So here we can call here our domain dot run. Okay, so we have here our geolocation repository, but here we're going to communicate to our API. You can see here we have to fetch the data, then we can save the data inside here. So this is the right time to create our factories for our database, for our API. So for this case, let's go directly inside here, and we want to create a new package here. So let's create here a new package, and this because we're going to use it with different. So let's call this common. And inside here, let's create another package. So we have the data, so we can have common with domain and other things. So for our case here, we're going to have this. So another case here is we want to create the HTTP client factory. So let's call this HTTP client factory. And since we're here, the mapper, we're going to use it with different features, so we can keep it inside here. Let's refactor this also. Okay, so everything looks perfectly. Okay, so inside here, we're going to create one function that is called create. And this one, we're going to provide it inside our Coin. And we want to pass in here the engine because this one can be specific differently. So we can pass in here our HTTP client factory. And this one is going to return the HTTP client, which can be used to communicate to our database. And inside here, let's now return our HTTP client. So we can just call HTTP client. And basically, when you hover around here, you can see this one is going to create a synchronous HTTP client with a specified block of configurations. So you can see this one requires different engines when we are communicating. When we created there, we used Darwin for iOS, KHTTP for Android and desktop versions, which are going to use JVM. So for this case, we are going to pass in here the engine that is just the, sorry, here we are not supposed to call HTTP client factory. It's actually HTTP engine. Okay. And inside here, now we can specify different plugins in order to make our HTTP client configurable. So we can install content negotiations and also logging and other things inside here. Okay, so inside here, we're going to perform several things. So the first case is we are going to install the content negotiation. So this one is going to communicate between the server and also our client in order to negotiate between the data that is going to be returned. And our data is going to be returned in form of JSON. So we want to configure the JSON that is going to be returned here so that we want to ignore unknown keys. So if the JSON returns unknown keys for the future, we don't want to crash our applications. And also we want to coerce the input values that are going to be returned. So sometimes they can be different. For example, they can be returned as long, and for our case, we have set them to be an int. So this one normally can crash our application. So we want to coerce that thing. And another case is we have HTTP timeout. So this plugin is going to allow us to deal with the request timeout, connection timeout, socket timeout, and other things. So for a case, we can set this to 20 seconds, or you can set it low in order to break the request. Another case is we are going to install the login, and this one is going to give us the capability to log different things. So for here, we can configure the logger. For example, here we want to log the message. So every time we send a request, basically we want to log it inside our console so that we can see what we are doing actually. And if we have any errors, we can see. And the levels here, we have different levels. So for example, here you can select the body, info, or headers and other things. So let's select all for a case in order to log everything. And here we can specify the default content type that is going to be used. And for a case, we are going to expect to receive JSON content type for this. So here we have our HTTP client. The next case is we want to make this as safe as possible when we are requesting our data. So we can make a safe request inside here our data in order to perform this. So let's create here a new file, a Kotlin file. Let's call this safe call. Okay, so to make here a safe call, so basically what we are going to do is actually create an inline function. So this inline function here is going to help us to make a safe request. So you can see here there are a lot of things which are going on around. So let me import here and actually explain this. Okay, so we're using this inline, and this is going to help us to optimize the performance by inlining the functions code at call sites, so we can avoid overhead from higher order functions, because here we are calling higher order functions inside our coroutines. So this one can cause a little bit of problems. So this one are going to be generally indicated to the compiler that, hey, you have to treat this function with caution. So for that case, we are using inline, and basically we're declaring here a function. And this is just an extension function inside our HTTP client. And actually we are calling this safe request. And here you can see we are using refied. So this one is going to help us to retain type informations of generic types at runtime. So basically at runtime, this generic function is not going to be available. So for this case, we want to tell the compiler, hey, you have to retain this so that we can avoid compilation errors. So if you remove this, basically you're going to, for example, get here some errors. So you can see this type T here, a compiler is going to shout to us because it doesn't know this at runtime. So we have to make this type T because we're using here inline. And this generally is going to help us to improve performance. And also here we have to use cross inline. And this one is going to actually prevent non-local returns statement from exiting the enclosure functions when the lambda is actually called. So we don't want to actually exit this at when we call a return, for example. So that's why we have to call here cross inline. And basically you can see that the block here, we are going to get an error. So we cannot inline the block here. It may contain non-local returns, and actually cross-line modifier is going to prevent the declaration of this block here. So we have to add that. So let's click here, add, and Android Studio is going to add this cross inline. Okay, so the next case which we are doing here, we want to emit first we are loading. So you can see here, actually we are actually performing loading. So we are emitting response.loading from our response class which we created. Now we can make the request, and here basically we are calling the request body inside here so that we can make the response. Now we want to emit the response that is actually successfully. So here you can see we are not using a try catch block, and here because we're using a flow, and flow has a mechanism of catching errors, and we have to manage this outside of the flow and not use a try catch block. That can cause some issues with, for example, cancellation exception that are thrown due to coroutines that are executed inside here. So we don't want to mess up with that. So for a case, we want also to manage this. Another case is we want, when the error is going to be thrown, then we can actually get the error messages and other things. So we want to serialize that error that is going to be. Okay, so the error that is going to be sent, we are going to create another inline function here that is going to help us to actually serialize this. So here basically we are creating an inline function, and similarly we are calling this response.exception. That is just the exception that is going to be thrown by our Ktor client. And here we want to get the error body, and this one is going to return us with the response body. So for this case, we want to try first to actually serialize this to get the body of that particular error. And if we have any error, basically this is going to be a serialization error, then we can just return null because we cannot serialize that. So now we can use here our catch block in order to actually catch our errors. Okay, so the next case here is we have our self calls. So we have to create our actually the geolocation remote API service so that we can communicate to our API service. So here we have our models. So let's create here a new actually Kotlin class of file. And here we are going to create an interface. Let's call this geolocation. Okay, so this one is going to be our geolocation remote API service. So here we are going to have a single function that is actually search the location. And here we're going to have a query that is actually a type string that is going to help us to search this. So this one is going to return us with the flow. And the data type here is the response class, which is just the response wrapper class. Okay, so here we are going to have the geolocation DTO because now we are inside our data and we are receiving this from our database, from our API. And here we're going to get the API response error as our error type. So here we have our interface and everything is working perfectly. So the next case is we can create our impl. For this case, let's create here and call this geolocation. So this one is going to actually inherit from the geolocation remote API service. And we have one dependency which we have to pass inside here. That is just the HTTP client. So let's create private val and call this HTTP client. And this one is going to be injected by a Coin. Let's press Ctrl I in order to implement that one function. That is just the flow. And this one is going to return us with this response class here, which we have overridden here. Okay, so now we want to make the actual request. So we can call here HTTP client, and we have that self request, which is just the function that we can easily make here to call our self request. But here we want to actually get the geolocation DTO. So we can call here geolocation DTO and the API error, which is just going to be returned. So we have to configure the URL that is going to be used here. So we have to pass in here the URL string. So for a case, we are going to use geocoding. So we can call here k.geocoding base URL that we are going to receive. Then we can append here with a different one. So okay, so here we want to append with the endpoint that we are going to receive, and the endpoint here is saved inside K geolocation endpoint, geocoding endpoint. So we have here our URL set up, and we have one parameter that we have to pass inside our URL, that is actually the name, which is just our query, which we are going to make the request. So here we can just call name. Let's pass in here our query to make our request. Okay, so next here, we are going to go back inside our, let's press Command E here in order to go back to our geolocation repository implementation. So here we have everything that which we require. So for a case, let's create here a private variable. And the first case, we want to get the geolocation repository, geolocation API service. So we can call here geolocation API service. And we're going to pass the interface one and not use the actually implementation. Okay, another case, we want to get the DAO. So we can call here geolocation DAO. Okay, so our mapper is going to be of type geolocation. So here we can use geolocation and geolocation entity as the mapper which we are going to use. So this one is going to help us actually during testing so that we can substitute with stubs or fakes when we want to actually test our code. That's why we are not using concrete implementation inside here. Another case is we want to get an external curating scope that we can use. So let's call this external curating scope. And this one is going to be of type curating scope. So we can use this scope whenever we want it here. So for example, here we want this geolocation to have the same instance and shared between different type of view models, because we're going to have different type of features. So we want to share this. So our repository is going to be a single source of truth. Okay, so here we have our geolocation and we want to get the geolocation. And for a case here, okay, so we can call here our geolocation DAO, and we want to actually get the geolocation that is located inside our database. Let's call get geolocation, and we want to map this. Okay, so here basically we are getting here a location, and this one is going to return it as a geolocation entity. Now we want to map this directly to our geolocation for our domain. So that's why we're using here geolocation mapper, and we are going to map to domain on null if actually it's nullable. And that's why we are passing here it. Okay, so one thing which we are going to do here is actually convert this to a hot flow. So flow generally by default they are called, meaning that they cannot start to emit values until we start to call collect. However, now we have two screens. For example, this one is going to be evident when we are going to use a desktop environment where we're going to be showing two screens at once. So when one screen is going to make a request and change the data, we want also to be reflected to another screen. So we have two view models here, and they're going to share the same geolocation. So we want if the geolocation changes from one screen, then the other screen is going to reflect. If you are using this in a mobile directly, then this is not going to affect you, because view model 1 and view model 2, they are going to be dependently created whenever you navigate from one screen to another. But now we want to make this actually configured. So for this case, we want to also make this share in, inside here our geolocation, because this is actually a flow. So inside here, we can just call share in, and this one is going to actually share the scope. So we have to provide that external scope that we are going to create here. And here we have to provide a mechanism that is going to tell, hey, when should I start to collect this or emit the values? So for a case, we can call here started, and we want to call sharing Leslie. So there are different types of this. So this means that sharing is started when the first subscriber is going to appear and never stops. So for this case, if we have one subscriber, that meaning the first view model is going to actually start to collect this, then this one is going to be sending the values until actually the scope is going to be cancelled. So there are others here. So for example, there is while subscribed. So for example here, when it's going to be subscribed, and then we can provide here the stop time mill out. So for this case is whenever there is no one that is going to be using this for a certain amount of time, then we can just remove it. And this one is going to actually started when the first subscriber is going to appear and immediately stop when the last subscribers is going to be disappearing. So you can use this. And for example, let's use here Leslie for a case. So inside here, let's create our function, and we want to call geolocation DAO. Upset geolocation, and then we can pass in here our geolocation. That is, first we have to map this because we're going to have a geolocation from our domain entity, and we want to map from domain and actually pass in here the geolocation that is going to save it inside our database. That's why we created two functions. So here, when it's coming from our UI, then we can map it directly to the data that is going to be understood by our database. The next case is we want to fetch here our data from the API. So inside here, we can just call return, and we want to get our geolocation remote API service, and we can perform our search location, and here we can pass in our query now. Now for this case, we have to map this because here you can see it's going to have different types. So here we have a response of geolocation DTO, but we are going to require this as a list of geolocations. So we have to perform a map function that is going to map this. And we can call now our response. So let's rename this as a response. So we have our map function that we have specified. Now we can use this as a geolocation DTO. Okay, so we have here our geolocation DTO. So one thing, we have not created the mapper for mapping this to our geolocation. So we can easily do this. Let's go to our geolocation DTO. Let's press Command E. Let's go to our DTO. And inside here, you can see we can create an extension function that is going to solve this issue here. So let's call this function. And we can call here geolocation DTO. Let's map this and call this to domain. Okay, so here we're going to return a list. Okay, so inside here we can now return our geolocation. So basically we are going to use this result and map this to our geolocation, and it's as easy as this. Let's import this. So we are just creating this result map. So you can see here we have our geolocation. So we can pass in the ID, and here we're using the flag URL, country ID, and other things. So this one is going to map to domain. So we can use this function as easy as that. So let's just go inside here, our geolocation repository implementation, and we can call this to domain. Okay, so we have here our clear geolocation. So for a case, we are going to call here geolocation, and we want to actually clear everything. So we can call here clear geolocation DAO. It's called geolocation DAO.clear geolocation. And here basically we can clear everything. Another case is we have an external scope. So if we want to cancel the scope before anything, so we can call here external scope.cancel. And here our repository is looking perfectly, and we are going to provide everything inside our dependency injection library. Okay, so you can see here we have external scope that we are going to create. This means we have to create a custom scope. So we can do this by creating inside here utils. Let's create a new function here. Let's create a new Kotlin file. Let's call this a scope. So we can add here our custom scopes, which we want to actually provide. So here we are going to create this external scope, And here we are providing the dispatcher, and we are having curating dispatcher, and by default we can use the default dispatcher. So if you want to pass in a different dispatcher, then you can use this function to actually create this. And after that, then we can provide here by using a supervisor job. So if you doesn't know about supervisor job, this means that the children coroutines, when they fail, they don't cancel each other. So one coroutine when fails does not cancel another coroutine. So that's why we're using here a supervisor job and not instead of a job. And another case we have here, the dispatcher is that. So here we are creating our coroutine context and returning our custom scope. So now let's go to our DI package. And inside here, so we are inside the common main, and let's go to our modules. So here we have a single dependency that we have provided that is for database factory. Now we can do for other factories here. So for example, let's provide here a HTTP client factory. Okay, so this one is going to create us with a HTTP client, but here we want to pass in the engine, and the engine can be different from different platforms. So for this case, we can use a Koin function that is called get. Okay, so another case here, we want to provide for external scope. So we have our external scope. So we can provide our curating external scope here, and we want to call .bind in order to bind this. Okay, so if we have any interface, then we can provide this with that particular. So you can see inside our repository, basically we are passing here a custom curating scope. Okay, another dependency which we are going to provide here is actually the geolocation remote API service implementation. And here we can do it by using these two columns here in order to provide that particular. So for a case, we want to use the geolocation. Okay, so here we can provide that particular item. So for a case is the geolocation. So for example, remote API, let's use here our import remote API implementation. So we can give it directly here by using the reference, that is by using these two columns here in order to actually import this particular geolocation class. The next case here, we can bind this to a particular interface. So for a case, we can call here .bind, and this here is going to take up a certain interface that is going to be bind for this. So whenever it finds this interface, then it's going to give us this geolocation remote API implementation. So it's going to give us the import. So for a case, we have here our geolocation remote API service as our interface. So here we are passing the implementation, and here we are passing the binding of that particular interface. Okay, so next here we want to create our other dependencies that we have here. So for example, we have the single off. So we want to provide a singleton for geolocation repository implementation. And here we can bind this to our interface. And similarly, for our mapper, then we are going to pass in this mapper here with geolocation and geolocation entity. And also we have here our geolocation repository implementation. So we're doing this twice. Okay, so no need to import it twice. Okay, so the next case here is, for example, instead of geolocation, we have the dependency for geolocation DAO. So we have for our location API, we have for mapper. Now the next case, we want to deal with geolocation for DAO. So for this case, let's go back inside here. We have to provide a single. Okay, and inside here, we want to get a particular dependency. And for a case, that dependency is actually, we can call it here. We want to get the geolocation database. And here we can provide our geolocation DAO that is directly here. And the implementation is going to be provided by Room database. So for a case, we can directly pass in here a singleton for that. And I think for now, everything is looking perfectly. So we can proceed to our UI part and create our. Okay, so now here we have our first item. The next case, we want to create our first feature, and we can easily do this by creating here another UI package. So let's create here another package, and let's call this UI. And inside here, we can easily create now another package. Let's call this. Okay, so here we can call our home screen, our home view model first. Okay, so this one is going to inherit from the view model class. Now, one thing which we want to do here is to actually provide the dependencies. So for a case, we want to get the geolocation here. And we want to pass in here the geolocation repository implementation. Okay, so the next case is we want to create here our state. That is a data class that is going to hold all the state which we are going to have. Okay, so here we want to create our home state, and this is going to be the home state. And here basically we are going to have our geolocation. So we have the first if there is a selected geolocation, and this one we can make it as a boolean. If there is no, so we can react this inside our UI. And also we can get the selected location that we have. And this is the query that the user is going to execute. And here we have if we are loading and whenever we have error and the geolocations that are going to be returned by our API. So for that case, we can create our state in order to observe that. Okay, so this one is going to be a mutable state of, and that is a mutable state list. So this one is a flow, and basically we can use it to observe inside our UI. Okay, so for the default value we have to pass in here is our home state. So we can call here our home state. Now we are making this private, so we cannot change it inside our UI. So the main changer of this particular state is going to be our view model. So we are going to expose here a read-only state. So this one is going to avoid us with a lot of issues. So the bugs which you cannot track. So for this case, we can call here our home state dot as state flow. Okay, so the first case we have the data saved inside our database. So we have to get that. So we have to get that data. So for this case, I'm going to create here a function that is going to be executed whenever we want to get this. So basically, we are communicating with our repository and we want to get our geolocation. So we're using here viewModel_scope.launch in order to execute a suspendable function. And the suspendable function is this collect here. As you can see, it is evident with this. So that's why we're using a viewModel_scope. So viewModel_scope is a scope that can be observed inside a view model, and it is going to be cancelled if the view model is going to be killed. So for this case, that's why we're using here a view model scope. Now we are calling collect here in order to start to receive the data directly from our database. So this one is like a pipeline of data which we're going to receive whenever it's going to change here. So when we receive the data is we have our home state and we want to update that state. So here we are going to have a state. This is a lambda call. So basically we're going to have a function that is going to be returned here. So that's why you can see we are going to update this. You can see we have a function that is going to be returning here. That's why we are copying this. So because our state is a data class and we cannot mutate it. So for that case, we have to copy in order to change that particular state. And here we are using selected location and we can change it to it. And basically this is the function that is going to be returned by collect here. So it meaning that it is the automatic returned value. So you can rename it as how we did here. Then we are checking here if is location actually selected. And here we are checking if it is not going to be equal to null, then this one is going to be true. So we can use this inside our UI. Okay, so we have here our geolocation. So the next step here, which I want to do is actually whenever we initialize our view model, then we want to actually get the data from our database. And basically here we can use our init block. And here basically we can call get geolocation. So this one, whenever is going to be called whenever we are actually initializing our database. Okay, so now here you can see we have our save favorite location and we're using here our state, but the state has no any event to actually update it. So for a case, we can add here an event that is called set selected location. So we're going to receive here the geolocation. Then we're going to use our home state here in order to update this. And here we can set our geolocation and basically is selected. We can change this back to true because we have selected a certain geolocation here for our case. So we can save it directly here that we have set something inside our geolocation. Now, another case is actually to make the request that is going to fetch and get the geolocation data. So let's do this here. Okay, so basically we have here a fetch geolocation. We're going to receive the query from the user that is going to be inside a text field. Now we are going to launch because we are performing a curating actually scope here. We are making a request. Now we can use here our geolocation and fetch this using the geolocation query function. Then we can pass inside here. And because this function here is going to return a flow, so you can see we have a flow response list of geolocation and the API error. So right now we can collect. And basically we have a reference of the result. Now we have our response wrapper class, so we can use that to actually pass our data and see if we are successfully or not. So for this case, we can use a when statement here. So inside our when statement, we can check if we are successfully. So now we can update our state by calling here home UI state and update it. And here basically we are passing is loading. Basically it's going to be false. And another case, you can see that when we are successfully, if we had previously an error, then we can set that error back to null. Then we can get the data by calling result.data because now we are in a success state. Now, otherwise else here, we are going to use the errors. So we had several errors, data classes, which we have created. So if we have a default error, so we can just write here, for example, it's loading, we can make it back to false. So we can remove that loading spinner. And the error here, we can say, for example, error card, or you can provide another meaning for data here. But for a case, we're just going to go like this for simplicity. Now, if we have any network error, so we can say here no network or network error, anything which you like for network error. And if we have serialization, we can say here we fail to serialize the data that is returned, or you can provide something more meaningful to the user. And if we have any HTTP errors, so we want to get that result code and we can send it back, or you can change it and wherever you like it. So for a case, we're just going to return the result code back to the user. And if we are loading, and here basically is response loading. So we have finished 2 our errors. So we can update here. So basically we can set is loading back to true. And if we had previously an error, then we can set this back to null because we are now loading. So for this case, we can remove and display the new error if we encounter another. So this one is going to be our function, and this is just the fetch geolocation. Okay, so our home view model here is complete, so we can deal with our screen here. Okay, so for this case, let's go directly here inside our UI package. So we're going to have multiple displays. So we're going to have desktop. Also, we are going to have, for example, running in a phone, tablet, and other things. So we have multiple OSs that can run our application with different screen sizes. So we can use, for example, a navigation type in order to show different types of navigation, so which we require. So for a case, we can create here another Kotlin class, and we can call this navigation type. So for a case, let's add this. So we have the bottom navigation, navigation rail, and permanent navigation drawers. And here we want to pass in the window sized class. And for our window size, and this one is going to return the navigation type. So you can have different types here. You can say, for example, compact and other things. So for a case, we have gone with these constants here. Okay, so here we can use a when statement, and basically we can check with our window size class. So we have several options. So for example, we can use our window with a size class. Okay, so compact, this one is going to be in a portrait mode for most fonts. And if we have other fonts, we can use a different types. So for a case, let's call here navigation type, and we can call bottom navigation bar. Now, again, here we can check for other aspect, and this one is going to be for medium. So for any medium, we can use the navigation rail. And if we have expanded, meaning that we have a big screen real estate, we can use, for example, navigation type dot permanent navigation drawer. And if this is not going to be inside this category here, and here basically we can return just the bottom navigation bar. Okay, so something like this, it's going to help us when we are dealing with our navigation types. Okay, so here we're going to call this search location content. Okay, let's make this as a file. Now we can create here a new composable, and let's call this search location. Okay, so here we have our modifier, and we have other parameters which we're going to need here. Okay, so these are the type which you're going to have here. So we want the navigation type to differentiate this. And also we have the state, the search that is going to be used. So we want to actually keep the state outside of this composable. So we want to make this stateless so we can use that state differently and react it differently other than we keep it here. Another case, we have the on-site change. This one can be called whenever the text field is going to change. Then on favorite click, if the user is going to click, hey, I want to save this as favorite. And also we have the on submit that is going to be submitted whenever the user click OK search. Another case, we're going to use the context here. This is going to be a platform specific context. And whenever we want to navigate back, we can use this on navigate back. Okay, so now here we want to get a state is whenever we are inside the expanded or not, because we're going to use here a search bar. So I'm going to create these two states here. So we have the expanded state and also we're going to have our padding. So this padding here is going to be differently. So you can see here we have our navigation type. If the navigation type is going to be of type permanent navigation raw, for example, we want to add a padding of 200 for our data, and else we can just return 0dp as our padding. Now, the next case is I want to create a box in order to create all of our search content inside there. So we can create here a box. Okay, so inside here, I'm going to pass in a simple modifier. Now we can give it a padding, and the padding is going to be horizontally. So we want to decrease the screen real estate for our data in order to make everything smooth. Okay, so another case is we want to make our content alignment, and now everything is going to be centered. So one thing which we are going to use here is a search bar. So a search bar is a material 3 composable. So we can call this search bar. And here we are required to pass in several parameters. Okay, so here we can pass in the content. And here we want to pass in the input field. Okay, so this is still in experimental, so we have to add opt-in. And here we can check if it's going to be expanded or not. So we can check here expanded. So by default, this one is going to take the expanded state which we have created. Okay, so here we can check for on expanded change. And whenever this is going to change here, so we can call expanded equals to it. Okay, so for our input field here, I want to create a row. So for this case, we can just pass in here two things that I want. So the first case is the icon button. Okay, so the icon button here is going to help us to use the navigation back. So this icon button here is going to be clicked when we want to navigate back. And the icon that we are going to use is the auto mirrored, and then we are going to use arrow back, and we can pass in the content description to be back. Now here for our search bar, we can use the search bar default, which is the Material 3 API, and use the input field that is specifically used for search. So for this case, we can call here our search. And another case is whenever we have the on search, now we can make the query changes to that text field. So on search is going to be called when we want to change our text field. Now on search is the email button that is going to be used, or for macOS and iOS, whenever we place return, then this one is going to actually send the request. So we want to call the on submit callback so that we can use it. And then here we have the expanded and not expanded state. So we can check it. If it's expanded, then we can change it here. Okay, so here we are going to pass in the placeholder. So this one here, we can pass in hinted search text. So you can say, for example, here, something like this, country search text. And basically here we can hint, hey, you have to search for a country. And here the leading icon which we want to show is the icon before. So we want to show this one icon here. And the trailing icon here, you can show more. If you want to add other functionalities, you can leave this trailing icon. Okay, so we have created here our text field. So you can see we have this text field here, which is going to be here. That is the search by default. Now, when we click here, we can see we have an expanded state that is going to expand. So this is what we have created here. Now, when we click here, search, and pass in here the hinted search text, for example, we can search for a country. So let's call here, for example, as, and you can see we are making a request and then showing the data here. A column here, and we're actually using a lazy column. So let's create this inside here, our content folder. So we have our search location and everything here is set up. So the next case is to create our search column. And here we can use a card to display the data that we're going to receive. And here you can try to align it to the center, or I think it's not looking perfectly for smaller screens. So let's leave it as how it is. Okay, so we want to fill max width and take the whole space there. Now we want to check if first we are going to make a request, then if that request we have any error, then we can show it here. We can use a simple animated visibility. And here basically we want to check if we are loading. So we can pass in here state.isLoading. Okay, so now we want to display the actual data, and to display that we can use a lazy column because the data can be a lot. So we don't know, and we want to make our application performant. So by using a lazy column, it's going to render the items that are visible only and not pass in a lot of items. So here we can call items. Okay, so if you have any error, you can place Alt Option to import that extension for items. Okay, so for our item here, you can see what we are creating. You can see we have an image, then we have the text, and then we have here a button that can be used as a favorite. So here we are doing a lot of things, and basically we want to make a request in order to fetch this flag. And we're going to use Coil image loading library in order to display this. And this request, we have to construct it here because we're going to fetch this from an API. Okay, so we have here our image request, and we're going to use the image request builder pattern to pass it. So this requires to pass in the context. That's why we're using here a platform specific context. Now we can look at the URL because we have here our geolocations, and we set up the URL inside our data here. So we can use our flag URL in order to make that request. And here we can call .build to build that request. Now, the next case is we are going to display 3 items. So when you look here at our design, we have 1, 2, 3. And these 3 items are displayed horizontally. So this we have to use a row in order to display it. So we can create here a row. Okay, so we want to customize this in a simple way. So the first case is we want to provide a modifier and give it a little bit of padding. So let's pass in here a modifier. Let's give it a padding of 16 dp. And another case is I want to change the background color. So the color of this particular selected item. So we can change here the color is going to be equal to our state.selected ID. Okay, so if this is the case, then we can return here a different color in order to differentiate this. So we can call here our material theme, and we can use here our primary color. And else, if it's not actually selected, we can return color.unspecified to actually use the color that is going to be. So let's call here color.unspecified. Okay, so the row here is going to not occupy any type of color if actually it's not selected. Now, the next case here is we want to create our flag image. So the flag image, we are going to reuse it to different screens and other places. So we can create this in a separate place. So let's go inside here, our components. Let's create another Kotlin class. And here, let's call our flag image. So we're going to create here a component that is called flag image component. So this is just a basic image. So let's create here a new composable. So this one is going to require image request. So here we can pass in the image request from Coil loading library. So sorry, image request. Another case is we have here a modifier, and by default here our modifier is going to have a size of 48 dp. If we want to change it, so we can give it here dot size. Let's give it 48 dp. So inside here we're going to use an async image, and here we can pass in the model. And for model here we can pass our image request. Let's pass in here a modifier. And from modifier, we want to clip this in a certain shape. So if you want to make it circular, but because our image are going to be rectangle, so I want to make them rectangular shape. Okay, so if whatever the time that we're going to receive, for example, we want to keep them rectangular. So for content description, I'm just going to keep it as null, and we can change here the content scale, and we want to make it content scale.crop if the image is bigger than the size. Okay, so that is our flag image. So we can go back to our search location content here. Let's call here our flag image, and we want to pass in here the image request. Okay, so I want to create another row here. So you can see we have two items here that are displayed. So I want also to display this inside a separate row, and this one, let's Control X and copy this. Now let's create here. And here for the first row, I want to push everything. So we can use here a horizontal arrangement, and let's call here arrangement dot space between. So if we have a bigger space, then we can push this everything to the end and avoid here. Okay, so with this another row here, I want to display something else. Okay, so here I want to arrange everything to the center, and we can call here vertical alignment. And we want to give it a width of 1F so that it can occupy and not push other things outside of the bound if actually the place is small. Now we can pass in here a flag image. Now let's add another spacer here. So we can use 80dp as our spacer. So now I want to display these two items. So you can see here, these are in a column format. So we can create here another column. Okay, so here we have our column, and I want to display several data here. Okay, so now here we have our row. So the next case is we want to display the button that can be used to click. So we have our favorite icon. So here I'm going to create an icon button. So here we are going to call the on favorite click on our click. Then here we can pass in the icon as our favorite. So that's why here we used a space between so that it can push everything to the end. So below our row here, we want to display also a horizontal divider that is going to divide between items. So we can pass in here a horizontal divider. Okay, so now here our search location is actually completed. So we can go directly to our home screen and create a home screen that we can use it. So inside here, let's create a new Kotlin class of file. Let's call this home. Okay, so inside here, let's create a new composable. Let's call this home screen. Okay, so inside here, I want to pass in several parameters. So one of the parameter is the navigation type, and here we can pass in the home view model. Okay, so we're going to use Coin here. So we can call here our Coin. So we have not created the implementation for this, but we're going to provide it inside our Coin module. The next case here, I have several things that I want here to use. Okay, so the first case is, for example, the state. This is going to be the state arising from our view model. So we can collect it as a state with life cycle. So if you know Android, we have life cycles. So we can use it in order to observe those changes and not recreate our state whenever the life cycle changes. Another case is we have the on search and the search. So this one is going to be a mutable state of an empty list. This one is going to be used inside our search bar so that we can use it. And in order to get the context, we can call here local platform.current. So to get the context, and this one is going to be a show search location bar, and we are going to use it whenever we have a lot of screen going on so that we can show this. Okay, so these are the state which I'm going to require for now. Okay, so for our search location content here, I'm going to use these variables here. So we can pass in here the modifiers that we require. And here we have the state, that is the home state we are going to receive. And the search is the state which we have declared here. And the on search is the changing of that, or when we want to set that search. And on submit, this one is going to be used to submit. So we want to fetch here the geolocation and actually perform that search request. And we can pass in here the search we have. And the context here, we can pass in here our context. And we have our navigation type. We can pass in here the navigation type. Now here on favorite click, actually we want to set here first the selected location. We can set it to it. And here basically now we can save the favorite location to our database. Then we can call again get geolocation in order to refresh everything. And here we can check if show search location so that we can change it. And for this case, so that we cannot show it. So you're going to see how we are going to change this. And here should show location, we can make it false. So when we implement that navigation system here, so for example, you can see here we have our navigation system. If we click this, then we are going to navigate back to our home screen when we want. Okay, so this one is going to play a crucial role, but for now we are just setting everything up for our future use. Okay, so before we try here to make other changes, I want also to change the navigation, the dependency injection. So let's go inside here, modules. Okay, so one thing here, we have a view model. So we have to tell Coin how to provide this view model. So we have a view model of function here, which we can use to provide. So we can call here our home view model. Okay, so we can use here the reference function in order to actually reference that view model. Okay, so inside here, our home screen, I'm going to remove everything. Okay, so we are remaining with our material theme class here. Okay, so we have to pass in here the navigation window size class. So for a case, we can call here a window sized class inside our app. And for that case, we can use our get window size, which is just the function that is inside our utils. Okay, so the next case is we are calling this up here. You can see it's going to be different. So let's go inside here for our Android and we can open up here our files structure. Okay, so we are inside here on main activity. So the first case is we want to get the calculated screen size. And this one is going to be different. So we can create here our screen size. And here we have to pass in the activity that is going to calculate. And the activity is basically inside here. Now this function here is still experimental. So we have to opt-in for Material 3 experimental APIs. Now we can pass in here the calculated screen size. Okay, so we can call here calculated screen sizes dot width class, and here we can get our window size. Okay, so another case for our preview here, we can provide a window size class. Let's give it for medium here. Okay, so we have for the Android setup. So the next case is we can set up for a desktop. So let's go, for example, here for our desktop. And similarly, here we have to pass in that. And what we can do here, let's create a variable and call this calculated. Okay, also here we have to opt in for Material 3 experimental API. So we can pass in here a calculated screen size and we want the width directly here. Okay, so similarly, we can go for our iOS. Let's go to our main view controller. And here you can see we are calling our app. Okay, so here we have our calculated window screen size for our app. So for this case, we can pass inside here now our calculated window screen size, and we can pass in here the width screen size. So now we can go back to our app. I think everything now is looking perfectly. So we can try to run it inside our phone or we can do it differently. So here I'm going to create another configuration and let's click this icon here that is going to add a new configuration and we're going to click Redo. So inside here, we're going to create another running. So for a case, we want to actually run our compose. Okay, so you have to type it as this one here. Let's click apply and click it OK. So this one is going to be our compose app run. So we can run this in our desktop environment. Okay, so when we try to run here, you can see our database factory is actually failing here and you can see it cannot infer this. And this is happening because of one thing. So you can see here our geolocation is actually set up inside our geolocation, but inside our, and when we go directly inside our geolocation database, you can see that we have changed this from geolocation to data. We refactored, so it is not changing from there. So for this case, we have to make here another package. So let's call this data. And for our locals, let's refactor this to here. Okay, so let's go to our database factory. You can see now we don't have that error. And also here on database factory. Okay, so now you can see our database factory does not have any type of error. So we can try again to rerun. Okay, so here is our app launched successfully. Okay, now when we try here to search, let's search for any country here. We get here an error card. Okay, so when we inspect here inside Android Studio, you can see we have a serialization error that it has an unexpected JSON token. There is a dot here inside a numeric. Okay, so I think this serialization here is happening because let's go inside here our common main source set, and let's go directly inside our geolocation and our remote. Okay, so let's go to our models, location DTO. Okay, so you can see here the elevation is actually returned as double, and you can see here, but the data which is going to be returned as int, that's why it's failing. So for here, we have to call this as double. Okay, so by default, let's make this 0.0. So let's try to rerun again. Okay, so our app is launched again. Now let's try to search here. So we can try to search for, let's search again, Finland. Okay, so now you can see the data is actually returned here. Let's try to save this. You can see these are not properly aligned here. So what we can try to do, let's go back to Android Studio and fix this. Okay, so basically here what we can do, let's go inside our search location. So inside our search location here, we have our rows. So one thing which I want to do is to fill the max width for this. Okay, so after we fill the max width, also I want inside this row, instead of arranging everything to the center, I want to arrange everything to the end. So now let's try to stop and rerun this. Okay, so here it is displayed again. Now let's try to call here, for example, Finland. Sorry, we have to fix this. Instead of and, okay, so I think I have made a mistake. Instead of keeping it at the end, let's give it at the start. Okay, now let's search again. Okay, so now you can see everything is displayed perfectly, even if the text are changing. And whenever we enter here the full mode, you can see everything is looking perfectly. So here we can save. Okay, so now I think for our search is actually working perfectly. Okay, so now we want to look at the weather forecast, and now we're going to use the weather forecast API, and you can get the data. So if you don't have this, you can just go below here and select the weather forecast API. Now, after this, the weather forecast, which we're going to do is to get the weather hourly variable. So you can try to test it here. We are going to set as 7 days. Then for hourly, we want to select these two variables, the temperature and the weather code that we're going to receive. So there are a lot of variables. You can try to pick which one you like. But for our case, we're just going to go with these two variables here. And for daily, we're going to select the weather code, maximum temperature, minimum temperature, and also there is no need for these two, maximum and minimum apparent temperature. So we want only maximum and minimum temperature. Then we're going to select sunrise and sunset and also the UV index. So this one is just enough for us. Now, again, for the current weather, we're going to select for temperature. That is going to be the 2 meter. And also we can select the weather code, the wind speed and wind direction. And also we can check if it's day or night. That condition is going to be given us. Okay, so after that, you can see here we have the API. So we can try to open up here. You can see this API call is equivalent to 1.3. So if you are using this in commercial purposes, basically you have to consider that. Now you can try to, for example, open up this in a new tab. Okay, so you can see here we have the data that is returned here. Okay, so for our case, we're just going to copy this. So select everything and copy it. Now let's go back to Android Studio and start to create our data. Okay, so this is going to be a new feature. So for this case, we have to create here another. So instead of giving it as the geolocation, we can create another package so that we can separate everything. Now let's create here a new package and we can call this actually forecast. And inside here, let's create a new, so we want to create another package. Let's call this models. And sorry, let's create here, this should be remote. For our model, let's move it here. Okay, so inside here now we can use our extension Kotlin data class from JSON, and we can paste this data here. Okay, so now we want to create our weather data. So let's call this generate here. So it's going to generate all the files. So you can see it has added 7 data classes. So doing this manually is going to be tiresome. So for this case, we have all of this. So you can see we have our weather DTO that contains the data. So you have to inspect here if everything is actually returned properly. Okay, so for our time here, for example, we can call this as a long. And for hourly, similarly here, let's call this long. And here we can call this as a long. Okay, so I think everything is looking perfectly. So I'm going to rename these classes to use DTO. So you can see here we have weather DTO. So I want to have current DTO, daily DTO, and hourly DTO. Okay, so I think everything now is looking perfectly here in case of our data. So another case here is I want to create inside our data is the, sorry, and here let's create our package. Okay, so inside here our data I want to create also the mappers because we're going to map this. So we can create here another package that is called mapper. Okay, so what we are going to map here is between the domain entity and also the DTO entities. So for this case, I want to create another package here. Sorry. Let's create a new package. And this one is going to be for our domain. And inside here, our domain, let's create the models. Okay, so inside here, our domain, I'm going to create these 3 models. So the first model is our current that contains these properties here. So you can see the temperature, time, and also we have the weather status. This is the weather status that we have created inside our utils folder. So we can use it here. We have the wind directions in terms of a string because we are receiving in terms of an int. So we have to change it. And also we have the wind speed and also is day. We can leave it as a Boolean function. Now also we have here, for example, daily. So for daily here, we're going to receive the temperature and the temperature max, temperature mean. Then we have our time, the weather status, and here we are going to return as a list of weather statuses and also the wind directions because we have 7 days here for daily, wind speed, sunrise, sunset, and UV index. So we are going to change this because we are receiving this sunrise and sunset in terms of int, so for in terms of long. So for a case, we are going to convert this by using our utils functions that we have created for date. And after that, we want to get the weather info. So we can loop around and create one weather info that we can easily use. So instead of looping again inside our UI, because here we are receiving a lot of lists. So I have created here a variable that is going to be of type weather info. So this one is going to return us with the weather info. So we can create a mutable state of this. So we can loop around throughout all of the items which we have. Then we can add them as the weather info here. So we can select the temperature max, temperature mini, and keep them inside a single data class that we can access that single data class to display all the variables which we have instead of keeping all of them as a list here. And this is the data class which we have created that is actually embedded inside the daily here. So I want to keep everything compact and not lose around the different places. So if you go to directly inside the daily, you can get this information here directly without going outside of this class. So it's going to keep us our class organized. And similarly for hourly, we are going to receive the temperature in terms of list, time, and weather statuses. So I'm going to create another variable that is called weather info. And here basically we are getting our weather informations in terms of a list. So we can keep them inside a single item. So we're going to loop around again. So you can use map indexed here to remove the brevity of creating several things, adding and removing as how we did here. So for that, we are going to pass in here our hourly info item. So for that case, we can pass in the temperature, time, and weather statuses for hourly. And for our weather, this is just a simple. So this one is going to contain all the items. So we have daily, hourly, and also the time zone, the current weather statuses, and everything else which we can try to use. So for this case, we can just directly go and use this inside our data here and convert. Okay, so I was thinking that we can use the previous mapper, which we have created an interface here. But another principle of clean architecture is that we should not make classes depend on things which they are not going to need. So here we're going to have three functions that we require to implement. So for this case, I can create a separate interface that only is going to suffice for our purposes. So for this case, let me create here another that is called API mapper. And let's have here only a single function that is called map to domain. Because here we are just going one way, one direction. We are not saving them to our database. I don't think we are required to create another function that is called from domain. So you can create these wherever you actually need them. So we don't want to add other methods that our class should depend upon. So for this case, we are going to receive the mode. And also here we can get our time zone so that we can use it to destructure the classes which we are receiving here. So for a case, we can just keep this as a string. And by default, we can just give it as an empty string if we don't have the time zone. Okay, so for a case, we can just return here the domain. Now we can try to create every mapper for our items. So for this case, let's start with our API with a mapper. Okay, so this class is going to depend from our API mapper. And here we can pass in for our domain is actually the daily item. And here we can pass in the daily DTO. So we have to pass in here several parameters. And I want to use some functions that are going to add readability for a case in order to pass our items. Okay, so inside here we have three functions. So we have the passing of the time. So we're going to receive the times in terms of long. Then we are going to also receiving a time zone so that we can format this. Because we are inside the daily, we can use format Unix today. So this one, we defined it inside our utils folder. So if you go to our utils folder here, you can see we have format Unix today. So this is how we implemented it. So for that case, we can use it here to map our time directly to strings. And instead of doing this inside our UI, so we offload all of those data inside here, inside our mapper, so we can map it. Another case is we want to pass our weather statuses. So we are receiving a weather code in terms of int. So now we want to return a weather status. This one is going to contain the information and also the drawable resource that is going to be returned here. So for this case, we have a function that inside our util is going to do this. So you can see we have this get weather items. So when you go to the starter code, you're going to get this. So you can see with the 0, we're going to return, for example, clear sky, and it's appropriate drawable for that case. So you can add here, for example, if it is night, and you can extend this. But for a case, we're just using this for everything. Now, for that case, also, we can pass here the weather direction. So we are going to receive the wind directions in terms of double. Now we want to do a simple mathematical calculation in order to get a wind direction. So you can see we have here wind directions. So our direction here is actually in terms of this, we have and actually use a 360 in order to get the compass. And here we are performing a simple calculation to get that particular direction. So for that case, we get the direction in terms of strings. Okay, so now we can use this inside here. Okay, so I think here we forgot to add two things inside here, our daily DTO. Okay, so you can see here we have our temperature, we have our temperature mean, and also we have our time. So I want to modify here our model that is actually our DTO to also contain the wind direction and also the wind speed here. So I think these two things I forgot to add them. So we can go directly inside our daily DTO. So we forgot to add this when we are copying that request from our API. Okay, now we can press Command B to go here. And here we want to add two items. Okay, so inside here, our daily DTO, I want to also include these two things. So we have our wind direction, that is the name from our API, wind direction 10 meter dominant. And also we have our wind speed, that is 10 meter max. And this one is going to be in terms of double. Okay, another case here inside our daily, I think our sunrise here is going to be returned in terms of long because we are just receiving a Unix timestamp. So this should be in terms of long. I think this one will look perfectly. So now let's go back to our mapper here. You can see everything now, no error which we are facing here. So what we are doing here is using the same properties and pass them. So for example, here our time, we can pass the time by using the time and also the time zone that we are going to pass it inside here. Okay, so here we can use our API mapper. And here we are going to use hourly and hourly DTO. Okay, so here let's add two functions. Okay, so here we have these two functions that is going to pass the time, and similarly we are going to get the time and map it, and we want to format this Unix to hour, and also we can get the code now inside our weather statuses, and we can use get weather code here and transform it. Okay, so the next case here is we can change our hourly. We can use model.code. That is the weather code which we have. Okay, so this one is for our weather mapper. Now the next case is when we want to map our current weather. So we can create for mapping current weather. So let's do this and press here, Command N. Let's create a new Kotlin class. Okay, so we are adding these three functions to pass the time, pass the weather statuses, and also to pass the wind direction. So here we can return our current weather. Okay, so here we want to return our wind direction. Okay, let's go inside here. So we expect to get a double. So we can change this to double. Okay, so now here inside our current weather, we are changing this as our temperature. We can pass our time, weather statuses, and we can pass the wind direction, the wind speed, and here we can check if its model is day. So you can see we are changing this to Boolean. So we can check here if the model is day is going to actually equal to 1. This one is going to be a day, and otherwise it's going to be false. So a simple check here. Now, lastly, here is the weather mapper that is going to combine all other mappers which we have. So for this case, let's create here a new class and let's call this API weather mapper. So this one is going to map all other items. And here let's expect for API mapper. And for our domain here, we are going to use our weather. And here we're going to receive all other mappers that we can use. So let's create here a private val and call this API daily weather mapper. Now let's change, for example, for our current. So we can use our current weather mapper and we want to map this to domain. Let's use model.current and here we can pass in the time zone. Okay, so here we have our weather item and we have mapped it successfully. So I think now everything in our mappers is looking perfectly. So the next case is we want to create our remote API service for our case. Okay, so the next case here, which we want to do is now to create our forecast tree remote API service. So now let's go inside here, remote. Let's create another interface and let's call this. Okay, so here we're going to have one function. So this function is going to actually fetch that particular request. So we can say fetch forecast. So for example, here we're going to have our latitude in terms of float. So by default, we can use this -6.8. Also here we can specify other parameters. For example, we have daily, current, and hourly. So we can keep this in terms of an array because this is how the API actually works. So I'm going to add this data. So you can see here we have our daily. And for our daily, we are going to pass in the parameters which we want. For example, the weather code, the temperature 2M max, temperature max, wind speed, wind direction, sunrise and sunset, and UV index. So we are keeping them as an array, and basically we can use them inside our request when we are sending it. Again, for our current, we can use again the array because here we have the temperature, is day, weather code, wind speed, and wind direction. Another case is we have the weather code, and for a case, we can pass in here the weather code and the temperature 2M. So these are the two parameters which we want inside our hourly weather. Then again, we have the time format. So we can use a Unix timestamp because we're going to convert this, or you can use ISO because they have also that format and the time zone here. By default, we are going to use this one here. Okay, so now here we want to provide that implementation. So let's create here another Kotlin class of file. Now this one is going to be the implementation. Okay, so this class directly is going to inherit from our forecast API service. Okay, so one class which we are going to pass inside here that we are actually depending is the HTTP client. So we can pass in here HTTP client. Okay, so inside here, we want to make the HTTP client and use the self request to make our request. Okay, so one thing which we forgot here is the return type. Okay, so this one is going to return a flow. Now here we can place option return and we can change this type. So our return type now is actually the response which we have. Okay, so we are going to return here a flow. Now we can use our self requests. No need to provide the data type. Okay, so inside here now we can make our request by passing up the URL and the parameters which we want. Okay, so here we'll have our URL. So you can see we're passing the URL as our forecast base URL. Then we can add a slash and pass in here the forecast endpoint. So the endpoint which we want to hit when we pass in this URL. Now we can pass in here the parameters. So you can see we have the latitude, and basically we're going to pass in the latitude and pass in it as a string directly here for our latitude. For our longitude, we can pass in here the longitude and change it to string. So basically we're going to receive this. Then we have our daily. So you can see we have the daily and we set them as an array. So for this case, we want to join them as a string and separated it with a comma because this is how our API is going to function. So we want to avoid a lot of issues. Again, here we have our current weather. So similarly, we can do that. And hourly, we can do the same to join to string. And then we can pass in the time format and the time zone. And by default, we have already set the time format and time zone. So the only parameters which we are going to change here is latitude, longitude, and the time zone because they are going to be different from different places. So we want to get the time actually correct depending on those time zone. So I think here remote API service is actually completed. So the next case is we want to create our repository. Is to fetch the actual weather data that is we are going to have here. So let's create our latitude. And also here, this is a float. And another function is the time zone. So we do not expect to change other parameters. So we are going to change only these three. Okay, so another case is we have here our repository. Let's create now a repository inside our data class. Okay, so we can pass in here the dependencies which we require. So let's create here our forecast. Okay, so we have here this variable as a straight flow. So this is just a read only. We cannot modify it. So we can create another that is mutable. So let's create here. We can make this as a private. Okay, so this one is going to return us with the response. And the response is going to be similar here. So we have our weather as state flow. So I think that is looking perfectly. Is going to perform that request, and we are not returning anything, but we're going to use this state in order to observe what we are fetching. So here we can call our forecast remote API service, and we want to fetch now that particular item. So we can change here, for example, our latitude and longitude. We can pass it here. Another case is we can change the time zone. Actually pass in here our time zone. Okay, so our time zone here is supposed to be a string, not as this way. Okay. Okay, so and our time zone there. Let's add the names to make this. Okay, so for this case, we want to map every item which we have. So we can call here .map because this is going to be a flow. So we can perform this. Okay, so here we have our response. Now we can transform the response which we have, response.map. This is the mapper that we have inside our response mapper class. And here we want to map it to domain, and we can use it in order to convert that to our domain entity. Now, after that, we want on each of each items which we are going to have to actually change the result. So here we are going to have our result. Now we can update our data. Let's call here update and pass in here the actual result that we have. So for this case, and also we can launch this differently. So let's call this launch in. Okay, so adding this launch in here is going to start to actually make this function here to be executed. So when we use on each here is going to transform, and we want to observe this data, and we are not observing the flow which we have here. So for that case, we are observing the state flow. So if we omit this launch in here, basically this one is going not to emit other values. Other than that, it's going just to give us a flow, and we are not passing this flow to our UI. So we want to observe this. So for that case, this on each to take place, we have to call this launch in and call external scope to actually execute this. So this is how flows actually works. You can see this is the terminal flow operator that is going to launch the collection of the given flow in that particular scope. So for that case, it is a shorthand for calling scope.launch and then collecting the items which we have. And you can see even the example here, which they have given us, is using the on each and other use cases. Here you can call launch in order to make it more declarative. Okay, so we have made a lot of progress here. So we are providing several dependencies. I think another case which we can easily do, let's go inside our modules folder. So we can press Command E or Control E in order to navigate to our modules folder. Okay, so inside here modules folder, we want to provide several dependencies that we have. Okay, so you can see we are providing the geolocation, also the geolocation repository, the geolocation mapper. Also, we have the forecast remote API service, and we are binding this to our interface and also our API daily weather mapper. So if we are going to use our API weather mapper in terms of an interface, then we can bind it like this. And here our API hourly, our API weather mapper, and also our current weather mapper, which we have. And lastly, here we have our forecast repository implementation, and we are binding this to our forecast repository. Okay, so we're going to add in terms of view models if we require them in the next case. So now let's deal with our UI part. Okay, so we have here our forecast. Let's go inside our UI. So another case is we want to create the package for our forecast. Then the next case here, we have to provide the parameters which we want, and that is our repository. Okay, so those are the two things which we want. And here we are going to have our data class that is going to stand as our forecast state. Okay, so this one is going to be our state, which is just the weather data. So here we have the weather, error is loading, daily weather info. So we can access our daily weather info and also the selected geolocation here. So now we can access here our state. Okay, so this one is going to be our state. So this is called forecast. Here we are using a mutable state flow, and similarly we are using the same pattern as how you have seen. Okay, so the first case is we want to get our geolocation. So we can create here a simple function. Let's call this get geolocation. And let's make our request with our geolocation repository. And here actually we can collect the data which we have. And basically here, let's update our forecast state. Okay, so here we have our state. We can call state.copy so that we can copy that state which we have. So we can change the selected location and back to it. Okay, so this one is going to be our first case. And whenever we initialize our view model, we're going to call get geolocation for the first time. Now, another case is we want to observe the weather data. So here we can create another function. Let's create this as a private function, and let's call this observe weather data. So here we can use our view model scope and call .launch. And basically now we can make our request. So let's call here repository.weather data. And here we're going to receive the response. So now we can look through the response and get the data which we want. Okay, so similarly as how we did before, here we have our response. So we are going to check if we are loading, then we can update our state to a loading state here. So you can see it's loading, we can make it to true. And if we have an error, we can set it back to null. Then if we are successfully, we are going to update now our state. So the first case is we are going to check if it's loading, and we can set back to false. And also this, and we can make it back to null and the weather response. And we want to get the today daily weather info. So we are going to find that items by checking if is today date. So if today is actually Monday, then we can check it as Monday. So this one is going to help us to get the today's date. Then we can update our today's daily info. And here we can get our data. Another case is when we have default errors, as how we did before, network errors, serialization, and HTTP error. And if we have another error, we can just leave it as how it is. Okay, so I think everything now is looking perfectly. We can observe our data. So another case is we can create another init block here, and we can call observe weather data. And we're using a different view model scope here to launch. Okay, so another function which we want to add inside here, our observe data here, is actually we want to fetch the data. So we have no any function that is going to help us to perform that. So we can create here another function. Let's call this fetch weather data. Okay, so if this is not going to be null, so we can use a latest scope function. And here we have our geolocation. And here we want to call fetch weather data. So we want to pass in here for latitude. We can call here geolocation.latitude and longitude. Similarly, we can use our geolocation. Now everything here is going to be perfectly. So now let's go to our screen and deal with this. So let's make this as our forecast screen. So the parameter which we want here is the forecast view model. And here we can directly use Coin. Another case is we have the on search click. So because here our forecast screen, on search click, we are going to display here also the search screen directly from here. Okay. And this one is going to return unit. So we can pass in here as a reference. Okay, so here we are going to have our state. So Let's import here the get and set value. So we are going to get our forecast state from our view model. And another case is I want to use a launched effect. So a launched effect in Jetpack Compose can be called whenever there is something that is going to change. Basically here we're using a selected location. So if the selected location is going to change in future, we want to make another request to actually fetch because our data is actually stale. So that's why we're using here a launched effect in order to make this. So for the first time, we're going to get the selected location, then we can make our fetch request. And after that, then we can now start to create our screen. Okay, so this is the screen that we want to actually build now. You can see we have here everything that is aligned in a center format. And also we have items that are displayed here at the top. So for a case, we want to use a box in order to create this. So we're going to surround everything inside a box. Let's create here a box and we can use that default modifier. So the first case, we want to fill the max width. Sorry, we want to fill the max size because here we are going to display everything. And another case is we can give it a padding of 16 dp and we can set the content alignment and we want to align everything to the center. So now we can deal with our content. And here you can see everything is arranged in a column format. So we can create here our column. Now let's pass in here the horizontal alignment. So we can call here alignment.center horizontally and vertical arrangement. So let's pass in here our vertical arrangement and we want to arrange everything to the center. So we can call arrangement center. Now, another case here is we want to check if we have something. So if we have any error, then we can just show it here. So let's call here our forecast state and check the error. If the error is actually not equal to null, then we have a problem here we can display to the user. So you can display anything else, but I'm just going for simplicity with a text. So let's call here our error that is going to be returned. And if we have a nullable error, then here we can say unknown error occurred. Now also we can check between two states if we are loading and also we are successfully. So we can call here our forecast state, check if it's loading. So if we are loading, we don't want to display any type of data inside here. So for the case, if this is going to be the true, then we can show a circular progress indicator. So let's return here circular progress indicator. And else here, if this is going to be false, now we have our data, so we can deal with it. And because here we have already dealt with when we have an error state. So for a case, we are going to deal with when we have else part. Okay, so inside here, you can see our data is actually scrollable. We can easily scroll in order to see everything. So for this case, let's create here a lazy column. So let's pass in here our horizontal alignment. And we want to center this horizontally and also our vertical arrangement. And we want to arrange this to the center also. Now we can pass in here for item that is going to be our items that are going to be here. So the first case is we want to create our current weather items and also our daily weather. So you can see we have this current, we have here our sunrise, sunset, and also our hourly weather items. So we can create these items below here. So let's keep our composable neatly organized. Okay, so below here, I'm going to create composables for different items. Okay, so here we have our current weather. And one text here which I want to create is the degree text. So let's go above here. And this is just the degree text. So this one is going to give us that something like a cycle above the Celsius degree. So this one using this U00B0. So we can keep it like that so that we can display it inside our text without further formatting. So that is simple as that. So we have here our current weather item. So here we're going to pass in a modifier. Then we are going to pass in the current weather. Now you can see our current weather item here is displayed in a form of column. So we have this. So we can create here our column and then we can align and also arrange this item center horizontally and center. So that case, it can keep everything to the center. Now we are going to display the first icon. That is the icon which we have here. So you can see we have that icon here. And we are using here the weather statuses, and because we have already provided this directly here, we can use the icon that is the composable. And for content description, you can keep it null because this is just for decoration purposes. And we can give it a size. So we want it to make it bigger, so we can use 120. If you want to use differently, you can use them. And we want to change its color, so we can use a tint in order to change it. So we can use on surface variant so that it can match the color. Otherwise, it's going to be black. So for that case, we can use on surface variant to change this. Then we can add a spacing, a little bit of a spacer. Now we can display our text. And here we're using our temperature. So you can see this is 27.8 degrees Celsius. So for that case, we are going to use this and add the degree text that we have added above to get that symbol. And we want to use this as a display medium to show it bigger. So this one is going to give us that feature. And also we're going to change the color to on surface variant also to match it. Then we are going to differentiate this with a 4DP, so we can pass in here spacer. The next case is we are displaying another text that is for weather statuses. So we can call here weather statuses and partly cloud, for example. So we can have here different aspects. So for that case, we are going to use body large because we don't want to clutter here our UI with big text. And for that, we are going to change also the color. And similarly here, we are going to change the wind speed. So you can see we have wind speed 10.1 km/h northeast. So similarly, we can add this formatting here with this simple concatenation of strings. So km/h, and then we can get our wind direction. And because we have already formatted this data in our mappers, so we have everything in a good format. And here we're going to use body medium. So here we used body large to create that visual hierarchy, and we can use also the color as on surface variant. So we have here our first item, then the next item here we can change. Okay, so the next item here we have the sunrise and also the UV index that is going to be displayed here. So similarly, we can do it here. Let's go outside here and create two composables that are going to deal for this. Okay, now let's import this. So here we have our sunset weather item. So you can see we are passing this item here with the modifier and also the weather info that we are going to use the daily weather info in order to display this because we get this from our daily state. So we're going to create a card. You can see here there is a card that is going to give us that background color. And we are giving it a padding horizontally of 8 dp. So we can push it somehow. And we are creating here a column to display this data here. So for our column, we want to arrange everything center. So we use center horizontally and center here for vertical arrangement. So we can create that text as, and we can use here headline small in order to make that visual hierarchy. Then the actual sunrise here, we are going to use it as a larger text. So we can use a display medium. Then for our sunset here, we can pass in the sunset and use body medium to make that visual hierarchy differently. So if you want to change it, you can tweak around here the things. Another case is we have the UV index weather item. So similarly, we are going to receive the modifier and the weather info that is our daily. And similarly, we are going to use a card that to give us that background and the column that contains everything center horizontally. Okay, now we have here our text. We can do as how we did before. So here we can use UV index, headline small, and here we're using a basic marquee. So sometimes this UV index is going to be bigger than the screen. So it's going to push it or make this UV index bigger. So if this is the case, we want to make it to occupy the same line and not actually wrap it, but it won't show all the items. So it's going to show something that is going to be moving here. The next case is we have the UV index text, and here we can use display medium. And lastly, we are going to display our weather info that is actually the partly cloud here. We can use our weather status.info and use body medium. And similarly here, it can be a longer text. We don't want to wrap it to a next line. We can use this basic marquee modifier to make our text more somehow find it more pleasingly. Okay, so the next case is we want to create this. You can see we have this card is going to display here today, December 9th. Okay, so I'm creating here an hourly weather item. So this is the weather item that is going to contain this. And here, basically, we're going to use a card. You can see we are using a modifier and fill the max width. So we fill everything. And we are going to create a row in order to display these two items here. And basically, we're going to use a space between in order to push everything to the end. So that's why we have this today and the December here. And we can give it a padding of 16 dp so that we can move the content a little bit from the edges of our card here. Okay, so after that, we can pass in here our text that is today. And actually, we pass in here the today's date. So we can use here utils.format Unix timestamp, and we can use the clock.system.now to actually get that particular time that we have today. And here we are dividing this by 1000 because we are dealing this in terms of seconds. So if you inspect this and press Ctrl B, you can see that we are formatting from epoch's seconds, and this one is going to give us in terms of milliseconds. So that's why we're dividing by 1000 in order to get the actual seconds. Okay, so for that case, we can change also the text style here to body medium. So this was the upper part. Then we want to have the horizontal divider to divide between these two items. So we can give it a thickness of 2 dp and use the on-surface variant in order to make it more vivid here. Okay, so we have used that, our horizontal divider. Now we can create our item. So here we are going to use a lazy row because our layer items, they are going to be many, so we don't want to cluster or make our UI non-performant by clustering with or rendering a lot of items which we don't want. So that's why we're using here our lazy row. So you can see here inside our lazy row, we are using the weather info that is hourly, and here we have another composable that is called hourly weather info item. So this is the info item that contains this information here. So this composable that is going to display here. So you can see we are displaying it as a column. Then we are arranging everything to the center and give it a padding of 80 dp. And you can see we have the text. The first text is the temperature, and we're using here the degree text and the temperature and using body small. And we can give it a little bit of spacing by adding here a space of 8 dp. Then we can display the icon, and this icon is available inside our info item. And lastly, here we can now display our text and in terms of time. So thus we have our hourly weather item. Okay, so now everything here is looking perfectly. So you can see we have all our items. So we can go back inside here, our actually hourly weather item. So we have it here. We can go to our forecast screen. And here we have our items. So we already created all the composables separately. So we can keep here our composable neatly organized. So I'm going to create these inside our items. So we can use our forecast weather items, and we want to check this. If it's not nullable, we can use a let scope function so that we can access it. So the first case, we can call here our current, which is this one here. Then again, here we are going to create our daily weather info, and that is going to display these two items. So we can check it also if it's not null so that we can display these other items. So we are displaying here the sunset. And also we can differentiate it by using a weight of 1f. So 1f here of a weight is going to push everything to the sides. So by adding this, it's going to help us to make that. And also we are going to use the UV index again and add here a spacer and differentiate between these two contents. And then we're going to create our hourly weather item, which is this one here. So we can give it the data that is the hourly weather data that it actually requires, and give it a modifier of height of 16 dp to differentiate it with the rest of the content which we have here. And remember that everything here is contained inside one item here. So you can see we have the first item, which contains all of this data. So the next item which we have to create is this particular graph here. So let's see how we can use this. And we are not going to use external APIs. So we're going to directly create this using a Canvas API. So let's see how we are going to do this. Okay, so now let's create here our temperature graph. And this graph here is going to be generic, so we can use it with any type of data. So for this case, I want to go inside here our components, and let's create here a new composable. Let's create a new Kotlin class of 5. Okay, now let's create here a new composable. So for a composable here, let's call this line graph. Okay, so we said this function is going to be generic. So for this case, we can give it type T so that we can use any type of data that we want here. So you can just configure these parameters here differently, but everything here is going to work similar. Okay, so here we have other parameters which I require. The first case here is we want the data points. So these are the points which we can use to plot our graph. So this one is going to be generic list of data. So we can pass in any type. And then we can map here X value mappers. So we can transform this from the T to string, and also Y value mappers. We can transform this from T to float, for example. So you can transform them to different data types which you require. So you can keep them both floats, but for my case, I've gone for string and float here. So we have Y-axis and X-axis values. Then we can give it the modifier, the graph title, which is optional here. You can pass in the graph title. Then the color. So for our color, we are going to use on surface variant. So it's going to look differently depending on different types of theme which we are going to have. So if we have a light theme, then we can display it in light theme. If we are in dark theme, then we can use that. Also the labels font size. So if we want to change it, but for a case, we're going to start with 12 SP. And here is the gradient color. So that color that is showing inside here, so you can look at our graph. You can see we have a gradient that is coming for our fill colors. So we can use here surface container highest, that to be the content for these particular items here, and pass in color transparent to create something like a gradient there. So I think that looks perfectly. Now, the next case here is I want to add several data. So the first case, for example, the padding here, we want to give it a little bit of padding. So let's give it 16 dp. So you can change it differently as how you want. Okay. Another case is we're going to use the text here to display. So I want to create this by using Jetpack Compose. We have to create one variable that is called the text measure. So let's call this text measurer. So this one specifically is used for our Canvas API. So here, let's create our Canvas API, and we can give it the padding. Okay, so the next case here is I want to define several parameters that are going to give us paddings and also spacing and make everything look perfectly here. So you can look at our canvas, you can see these things, they are not intertwining so much. So we can create here parameters in order to configure this throughout our canvas. So we have to do this manually here because this everything is going to be our case. Okay, so we are going to get first the max width. For example, here we have the size.width and also the max height. So here we are adjusting padding for labels. So you can see we have x-axis padding. So these are just trial and errors that in order to get something that is perfectly matching there. Okay, so here I have used the 60F and y-axis padding. So I have used the 80F and also the graph padding that is going to be 50% F. Okay, so I can use the graph width and the graph height by using the max width and subtracting with the y-axis padding and graph padding, so that to give everything else to be inside the graph. So you can see here inside our graph, we have a little bit of padding and everything is breathing inside here. And also the graph height, we can give it as that. So the next case is we want to determine the range of our y values and different values that we can use them. Okay, so the next case is we want to determine the y values. So basically here, I'm going to add other for determining the y values. So here, basically, we want to get the y values. So we can get this by using our data points.map, and we can use the y value mapper here to map them because we're using generic here and get the y values directly. So we can get here the max y values by using y values max or null, and also the minimum value and get the y range here. So this way we can determine the coordinates. Another case is we can use a simple mathematical geometry in order to determine the x intervals. Okay, so the next case here is we have our y-axis and also we have here our y values. So we want to determine the scale factors and also graph our coordinates. So for this case, I'm going to add these two variables here. So we're using basic geometry here. So we want to get the x interval. So we're going to divide the graph width with our size here in order to position them evenly inside here. So we're going to use this core as at least one values, so we can ensure that this value is not less than the specified amount. So for this case, we can make it to get the x intervals, so the intervals between items in our x-axis. Then again, we are going to determine the y range, which is just the scale factor. So if the y range is going to be greater than 0, so we can divide the graph height with our y range in order to determine now the y units that we are going to have. So we are mapping here to get the graph coordinates by using this simple mathematics here. So we can create here our data points. So we're going to create here an offset. So you can see we are going to use data point. So we want to create here our offset for our x values. So we can use here our y index padding, and we can multiply this by using the index and the x interval. So we can know if we have 5, then we can add that index and create that the x axis to create that the offset of that particular item. Now here we are doing some simple mathematics calculation in order to invert, because our canvas here has a top left corner. For example, our 0,0 is going to start from the top left corner going to our bottom screen. So for this case, 0,0 is going to be on top of here, coming down here, and not starting from here. So we have to invert our data point by using here our max height. Then we can get the spacing evenly here first. Then we can do this by mapping this. So we can use here our y value mappers and subtract with the minimum value and multiply by y unit in order to create that. So for this case, each data points in y coordinate is going to be computed by inverting its value, since the canvas origin is at the top left corner, as how we have said. Okay, so now here we have our points. So we want to display that particular field. So you can see here inside we have that field, and then it's going to be displayed below the lines here. So for this case, we want to draw first the fill. So we're going to use the path. So here we're going to apply, and we're going to use the points. So for each point here, we want to go for each indexed, and basically we start to move from each items. So you can see here, we're going to move from each items, starting here from our point that is going to be X, and the y-axis is going to be max height and minus x padding. So this one is going to be our starting point. Then we can move to the points from point x to point y in order to draw this until the end. Now after that, then we can go to our last index here and draw that by closing this. So for example, if we start here, then we are just going to create the fill until here. So we want to go back and close our path. So for this case, we can have a smooth background that is showing there as our gradient. Then we can close here our path. Okay, so now here we have our path. We have not drawn anything, so we used just the path from here to create our gradient fill path. Now we can perform the drawing of that particular path. So we can call here draw path, and we want to start by using this path here, and we can create a vertical gradient in order to create that. So we can pass in here the gradient colors. Then we can provide here the start y, that we can use the max height minus x axis padding, so that we can give that the room of breathing for our graph. Then we can give it the graph padding here to get our path. So I think everything here is looking perfectly. Okay, so the next case here, which I want to do, is now to draw the lines here. So you can see we have here our lines that are going to be drawn here. Now we have here our data points that we have created our offset inside here. So we want here to loop around through this. So here I'm going to create something that is going to be simple. We're going to call this points.zip with next. So here we can have two items in terms of pairs. So the first item, then the second items here. So we're going to, so this one is going to enhance the readability and avoid manual iteration by using the for loops. So for this case, we can loop through around here and get our start and end. So for that case, we can pass in here our start offset, where we're going to start to draw our point. So if it's going to be starting from this particular point, then going to the next point, then we can do that. And then here we can have our end, that is just the offset which we have created and calculated from our points here. So now we have drawn our lines. The next case is, you can look here inside, we have our labels. So we have the x-axis labels and y-axis labels. So now we can try to draw these labels. Okay, so for now, let's start to draw our x-axis here. Okay, so here we have our labels tape. So we don't want to clutter our UI with a lot of labels. So let's say we have 24 hours. So we don't want to cluster our UI with 24 hours graph data points. So we want to only display 6 items here, for example. So for this case, we can use our data point.size and divide it by 6 so that we can get the label frequency of the data which we want. So we can adjust it for wherever you want. Then we can loop around through the data points which we have. The first case, we want to define the exposition. So here we are going to get the Y padding that is going to give us the padding of our items and make it breathe. Then here we are going to use index multiplied by the X interval. So this one is going to help us to space it evenly throughout our positions. So if we have the first one, the second one, then they are going to be positioned well. Another case is we want to get our offset of our particular text. So we want to center it. So for this case, we can use exposition and we can account for our label size, font size in order to keep it at the center so that it cannot go left or right. So for this case, we can perform this simple calculation here. Also, we have to determine here our y-axis, so we can use max height minus x-axis padding, and we want to add a little bit of padding here in order to make everything breathe perfectly. Now for this case, we want to display that particular label. So for this case, we want to get the index of that particular labels tape. So for example, if we have the 10th item that is supposed to be displayed, then when we take the 10th item divided by the labels tape, then we are going to get 0 here. So basically here we are using a remainder in order to check this. If this is going to be, for example, the first item is supposed to be displayed, then again, after that, the 6th step is supposed to be displayed. So for taking that 6 divided by 6, the remainder is going to be equal to 1. So basically, we're going to return here 0. And for this case, we can draw it. Another case, if we are going to have the next step, that is going to be the 12th index, then when we divide by label text, label step, then the remainder is going to be 0 again. So we can draw it. So that's why we're using this here. Okay, so the next case here we have our x-axis. Now we can determine the y-axis. So you can see here we have the data points. So we have to determine first the minimum value and the maximum value. Then we have to determine the spacing here and make it perfectly. So for this case, we can perform here simple calculations. Okay, so here we can get the y values of our y. So here basically we want to space it in so we can use here our minimum value, then we can space it evenly by using here our y step label in order to get our y values. Another case is we want to determine where is it going to be drawn inside our y-axis. So you can see here we have our first item is 25, then we have 26, and there is a spacing here, so we can move them upward. So in order to move them, we can take here first the max height and minus the spacing padding so that we can keep everything breathing. Then here we can move this by subtracting with that step what we want. So every item is going to have a different steps, otherwise they are going to be drawn in a same position here. So we want to move this to one step here. So that's why we're going to use I minus graph height. Okay, because we are starting from 0 to 5 here. So for that case, we can give it 6 items. So that's what we are doing here, actually, to move them upward. Okay, so now here we are going to pass in our text measurer, and then here we are going to pass in our text. So we're going to use our y value, then we want to round it to an int value. So we don't want to provide here a float that of 0.55 or 0.2, that is going to be a double. So for that case, we are going to also pass in here an offset. So we want to vertically align it to the end. So for this case, we can use this y-axis divided by 2 minus label font size. So this one is going to position the label to the left of the graph. And otherwise else, we are going to check for our y coordinate here. So we are going to use the y position minus the label size and divide it by 2 so that we can center the label vertically within the respect to its baseline. So for this case, we can use this as centering our text here, and vertically they can be centered, and this way we can push it to the left of our graph so that we cannot clutter our UI with the graph which we're going to have here. Okay, so now here we have our graph, and we have drawn here our y-axis and our x-axis labels. And the next case is we want to display this temperature over time here. This is going to be something like a title. So you can see we want to position it at the bottom of our graph and actually make it center inside here. So we have to determine the horizontal alignment and also the vertical alignment, which we're going to give it here. So for now, let's draw here our graph. Another case. Okay, so now here we want to draw our label. So let's draw here our title. So this one is going to be optionally. So if the user is not going to provide the graph title, then we're not going to draw this. So the first case, we want to measure here our text. Okay, so we are going to pass in here the text measurer, and then we're going to pass in here the graph title. The first case, we want to center this. So you can see here the text is actually centered here inside our graph. And in order to do this, we are going to get first the max width and divide it by 2. So this one is going to measure the width of the title and actually help to calculate its horizontal alignment. For this case, when we divide this, it's going to center it at the middle of the graph area. Now, for that case, we are going also to actually subtract the title's width to ensure that the title is actually centered. So we can use here our text measurer and measure the graph that is the width. So we can get that width, and then we want to divide this by 2 in order to get the spacing of that so that we can make it to the center. So here we are determining the horizontal alignment, and basically here we can just center it below, just a small below inside our Y padding here. So you can see we have our Y padding that is going to be given here. So we want to subtract it by, we want to divide it by 2 in order to center it. So for that case, we have determined the width. So we divided by 2 and measured the size of this text here, and actually accompanied that in order to determine the max width here. So we can center it horizontally. Okay, so to recap here, we have two things. The first case is we are going to get the max width and the max height. That is the size of our canvas, which we are going to have. Then we are going to display here our paddings and also determine the graph width and graph height by subtracting all the paddings and x-axis and y paddings in order to create the graph width and height here. So after that, then we are going to determine the range of our y values in order to get our y values. So here we can get our y values, and we want to get here the range. So for this case, we can take the max and the minimum value and get our range values here. Then the next case here, we want to also map our data to get the x intervals. So for this case, we used this simple formula here and also get our y units that we can use to display here. Now we can plot the graph inside here by using these points, and basically we can create now our offset in order to use it later in our paths when we are drawing here. So you can see we draw a gradient fill so that we can fill our graph. And basically here we created a path that is going to actually draw that. Then drawing the path here by using this composable here is going to actually draw that particular path here. Then the next case here, we want to draw the line. So we used this zip with next in order to combine all items inside a pair so that we can have a start and end. And basically for that case, we can know our start is going to start here and our end offset is going to end here, instead of using our own iterations here and nesting multiple iterations. For this case, we can use zip with next, which is just a convenient function in Kotlin. Another case is we want to draw the x-axis labels, which we have. So we are going to go with 6 items here. And for each items here, then we have drawn by using these simple calculations here. And also we can draw our y-axis labels. And here we have used also an iterations and a simple calculations to draw here. And then here we have our graph, and we want to be centered it in our canvas. So we have done this here. Okay, so that was a lot to take in. So I think this one is worth the time to take it, because you are going to create your custom graph that you can use it in any project that you want, because we have used here our generic, and basically you can use it in different places. So let's go back here inside our forecast screen and create another item so that we can complete here our screen. So let's import here our function. So we are going to get here weather data, and we are going to use let scope function here to filter if we have any null values. Okay, so for our case here, we are going to draw hourly weather data. So we can use here weather information. So we can use X value mappers. So we want to map this by using the time. So for example, here the X axis that is going to be displayed here. So you can see we have here our time that is going to be displayed. Then also we have our Y value mappers. Then we can get our temperature. And basically here you can see is the temperature that is going to be displayed here. We can change them back to float. Then here for our size, we want to fill the max width, and the height here, we are going to give it 250 dp. So you have to give this because otherwise else then the graph is not going to be drawn. So you have to give it a specific height for our case and the width. And the graph title here, we want to call it temperature over time as how we have done here. So you can give it a different title. So now here we have completed to create our graph. So that was a lot to take in, but congratulations on completing this. Okay, so the next case here is I want to create is, so our screen here is actually completed. So you can see we have everything that is supposed to be displayed here. Now we want to display this here, and we can easily do this below. So let's go below our column here. So because we are inside the box, this one is going to be displayed on top there. So we can configure this. So for example, here we are going to create here a row. Okay, so here we're going to create a row in order to display these two items here. So you can see they're displayed in a row format. So we want to center everything so that we're using center vertically and center horizontally. Then again, here we're going to use the modifier and we want to align it to the top end. So you can see it's aligned to the top end here. And we want to make this clickable here. So we want to use the mutable interaction sources in order to create a repo whenever we click it. And also the on click here, we can call on search. Now we can look here for selected location if it's available. Then now we can make a request to fetch an image for that particular flag, which we have. Then we can display here the text to have the name, and we can change the colors to use on surface variant here. So that is the case. So we are just displaying this image and we are fetching it from the internet. And here we are displaying our text. So I think here everything is looking perfectly. So the next case here is we can create our something like a navigation that we can use to navigate, because now we have our forecast screen and also we have our search screen. So we can do that. Okay, so now here let's go to our home screen. So let's search here, press Ctrl E and go to our home screen. Okay, so literally now we have here our home screen and we are displaying just the search location here. So for this case, we can use here animated visibility to actually hide and show. So if we want to show the location here, basically we can show it. Then we want to pass in here the modifier to use the modifier here. Okay, so I want to move this content here. So let's just highlight and press Option Shift or Alt Shift in order to shift this content. Okay, now let's space it correctly. Okay, so you can see we are using here animated visibility and we are using here show location. So if this is going to be clicked here, we want to actually show it. And this one is going to be clicked when we have on search. So the next case here is I want to display. Okay, let me add a little bit of fonts here. Okay, so first we have here our show search location that is going to be shown here. The next case is we want to show if this is not going to be available. So if this is going to be false, then here we are going to show the location that is going to be our data that we have here. So forecast screen. And whenever we click on such click, basically we can change here the show location in order to show it. So you can see whenever we click this, you can see that this is going to be displayed now. We are using animated visibility. And when we click this, then we are going to navigate back to our screen here. So you can see everything here is looking perfectly. And if nothing, so we can say, hey, please select a location to get started. So you can show different different text that is required if the location is actually not available for our case. Okay, so I think we have made a tremendous amount of code changes. Another case before we try to run this, we can go to our DI package. Sorry, we can go to our modules. And here we have to provide the view model. So we have the home view model. So let's call here our forecast view model. Okay, so I think now let's try to run here application and see the code changes we have made. So when we run here application, you can see that it's displaying Finland, but we can see here an error occurred. So when we click here, okay, it's changing also. So let's try here, for example, to search for a different country. Okay, so we're getting here an error occurred. We can try to investigate this inside Android Studio. So let's go back to Android Studio. Okay, so you can see also here it is expecting that we are receiving dot symbol. So I think for our elevation path, okay, so I think this is a serialization problem which we are receiving here. Let's go to our forecast and let's go to our data. Let's go to remote here and look for our models. Okay, so you can see here inside our weather DTO, again, we are getting here as an int. So this one is supposed to be double. So we have to cross check. So you can see that this elevation is supposed to be double, but it's going to return here as an int. So when we did that, now let's try to rerun again. I think this is going to fix our issue here. Okay, so when we try to run again here, you can see that we have a problem that our progress bar here is just spinning infinitely and nothing is changing. So this is actually a problem. So let's go back to Android Studio here. You can see that it is caused by a dead time exception. So I think we have a little bit of problem here and we can try to fix this. Okay, so the problem here is happening because of one thing here is that we are not passing a valid option for trying to go to map here. So when you go to map to domain, you can see we are passing here a so when we press this, you can see we have here the time zone, and this time zone here is going to be used to map this. And actually we are just passing here an empty string. So let's go back inside here our forecast tree tutorial, our forecast tree repository. You can see that we are passing here the domain, but the time zone, we are not passing it directly to our mapping function. So let's pass in here our time zone. And actually, let's pass in here the time zone. So I think here everything is looking perfectly. Let's try to rerun again and see. Okay, so now everything is looking perfectly. You can see that. Let's try to open up here. We have our chart. We have here our temperatures. Now you can see we have everything. So I think everything is looking perfectly. So the first screen for our application is actually complete. So now let's deal with the next screen. Okay, so now here we have to deal with our daily screen. So we can easily create here our daily screen. Let's go inside here UI because we have all the preliminary data that we can create our home screen. Our daily screen. So here we can press Command N and create a new package. Let's call this daily. Okay, let's create here a new Kotlin class of file and we can select file. So for here, let's create our daily view model. Okay, so here we're going to pass in our variable that is just our daily. Okay, so here we have our daily state and we have declared here a mutable state flow. So the next case here is we want to observe the weather data that is going to be returned. And basically the observation here is going to be similar to what we had before. Okay, so before here we created a variable that inside our repository. So you can see here inside our forecast repository is that we have here a private weather data, and here we have a weather data that is a state, and we can use this to observe in different places. So one of the places is inside here our daily view model where we want to observe this. So I'm going to add this data that is called observe weather data inside here our daily view model. So this one is similar to what we did before. Okay, so here we have our observe weather data. So we are observing here, we're calling our repository and we want to observe the same state here. And you can see we have the response loading. So if we are loading here, we can just change our state to show that we are loading here. And here we have our daily state, which is basically the state that we're going to receive. And here, if we have any errors, then we can just easily observe them here. So one thing which we have to do is to call this observe weather data whenever we initialize our view model. So below here, we can just call init. And inside the init block, we can call here observe weather data. And now everything is going to be observed. So the next case here is to deal with our screen. So let's create here our daily screen. Let's go directly inside here our daily and create a new package. Let's create a new Kotlin class of file and let's call this daily screen.
Okay, now let's create here a new composable, and we want to call this daily screen. Okay, so inside here, we want to get the reference for our daily view model, and directly here we can use our Coin view model. Okay, so the next case here is we can get our daily state. So let's create here a variable and call this daily state. Let's use a by delegate, and we can use our daily view model. Okay, so here we have our state. The next case is we want to create another state that is going to be for the selected weather index, because when we are using our weather data, then we can change differently on different date so that we can see it. So we want to select a reference for this. So we can create here a selected weather index. So this one is going to be mutable state of 0. Okay, so another case is I want to get a reference for a daily item that is going to be selected. So we can easily create here a variable that is we're going to remember. So we're going to call this daily weather item. And here we can use a remember and pass in here two keys. This state here is going to be dependent on this. So if the weather index is going to change and the daily state here, so that we can easily get that particular item. So sometimes the daily state can change here. We don't want to keep the reference of the previous item. So for that case, we can pass in here two keys in order to recompose this state here. And basically, we are going to use our daily state and get our weather info, and we want to perform a get function, which is going to return us when we pass in that particular index. So for this case, we can get here our weather index. Okay, so this is going to be a pretty straightforward because we have created a lot of items previously. Okay, so one thing here is we want to create a column that is going to keep all of our items here. So when you look here at our daily item, you can see we have these particular items here. Then we have here a residual that is going to display different days here. So you can see, for example, we can select Thursday, we can select Wednesday, and whenever we select here, this is going to change with that particular data here. So for example, when I change here, you can see the data is going to also change, and this is going to be the case here. Okay, so we're going to keep everything inside the column here, and then we can display other items that are going to be required. So the first item, I want to arrange everything to the center, so I can provide this data here. Okay, so now everything here is looking perfectly. The next case is we want to check here our state, so I'm going to use a when statement. So we can call here a daily state dot is loading, so that we can see if we're loading, then we can show a circular progress indicator. So if this is going to be true, then let's show here a circular progress indicator. And if this is not going to be true, so we can just use here an else and keep everything organized inside here. Now our items here, you can see when you look, it's actually scrollable. So what I want to do here is to use a lazy column to keep everything neatly organized. So let's create here a lazy column. And for a lazy column here, we want to pass in the horizontal alignment. And here we want to align everything center horizontally. So alignment.center horizontally. And the vertical arrangement, we want to arrange everything to the center. So we can call arrangement.center. Now the first, we can create here our item. Okay, so when you look here, you can see we have a text that is going to show the maximum temperature and the minimum temperature. Then we have here the text 7-day forecast so that we can show it here. First, we can call here our current weather item so that we have that weather item, and we want to use let because this can be nullable for the first time. Okay, so now we have here the reference that is not nullable, so we can create here our text. So we can use here our temperature max and our minimum temperature. Let's change here our style. Let's use our body large here. We can use on surface variant here. The next case, let's pass in here a little bit of a spacer. Let's give it a height, and we can use 8dp. Okay, the next case is we want to create another text. So we can just copy this. Let's press Command C and Command V to paste here. Okay, so the difference here is the text. So instead of passing this, we can just call 7-day forecast. And here we can use headline small to keep everything as a small headline. Now, after that, we can just keep here our spacer in order to differentiate this with the rest of our text. Okay, so here we are displaying our current items here. So you can see we have this text. So we have the max space and here. Now we want to display these here. And this is going to be inside a lazy row. Inside here, let's create another lazy row. Okay, so here we can access our daily state again. So we want to create here our item, and here we're going to create items indexed because here we have the reference daily. Let's call this daily. And because here we're going to get the index and weather info, which are two items that we are going to override here. Okay, so we have here our items. The first case is when you look here, you can see there is a different case. So when we have selected an item, it's going to have a different background. And for this case, we can create a way which we can keep track of this. So the first case is to check the selected color. And here we can check if we have our weather index is going to be equal to the selected particular index. So for that case, we can use the inverse surface because that is the items that has been selected. And if not, then we can just use the container color, which is the default color for that particular item. Okay, so we want to create here our daily item. So we can create a separate composable that is going to show this particular item. So let's create here a new composable and we can call this daily weather item. Okay, so inside here I want to pass in several parameters. So we have our modifier and here we can pass in our weather info. And again, the background color, which is going to be different. And the on click, that is going to be the event that is going to be invoked whenever we click our item. So this one is going to return us with a unit. Okay, so we have here to create a card in order to display that particular item. And the card can have the on click. So we can pass in the reference for that on click here. And let's give it a modifier. And we can use our default modifier and give it a padding. And here we can use 8dp. And the next case is we want to change the colors for that particular item. So let's use our card's default and we can use the card colors here. Now what we want to change is the container color and we can use our background color to change that particular item. So inside here, we're going to create our items and we're going to use a column. So we want to arrange everything horizontally center. So we can center it horizontally and also the vertical arrangement, we can make it center. So here we're going to display our weather. That is just the temperature. So we can show it here and we can use body small. Then we can pass in here a spacer to differentiate it. Then we want to show the weather icon. So we can use our weather information and pass in here the weather status and the icon of that particular. And then we can pass in here the weather information, that is just the time. So this one is going to be made in terms of time. Okay, so we have here our daily weather information. So we can go and add that inside our lazy row. So let's go inside here our lazy row and we want to show here our daily weather information. So we can call here our daily weather information. And the thing which we want to change here is the weather information. And we can change the background color, that is just the selected color. And lastly is the on click. So whenever we click here, we can change the selected weather index. And we can make this to be that particular weather index. So now we have our first item that is already shown. Next, we can just copy here our spacer. Let's just copy this, press Ctrl C, with the information for this particular item. Now, the next case here is we want to display here the weather information's item. And here, basically, we want to show about the wind and then we want to show the wind direction and other things. Okay, so the next case here is we want to create the information about our wind. So let's create here another item. So we can use here our current daily weather item. And here we want to get now the information. So we can use a let scope function to access this. Okay, now here let's create a card in order to display that particular item, and here we're going to create a column. Now inside this column here, I want to modify it a little bit, so we can pass in here modify. So let's fill the max width first and give it a little bit of padding. That is going to be 16 dp. Then we can pass in here the horizontal alignment, and we want to align everything to the center, so we can call center horizontally. Okay, so after we create here our column, we want to add here other items which we're going to have. So I'm going to add them here directly. So this one is going to be the information about our wind. So we're going to get here a row in order to display that. So we're going to create here an icon, and inside this icon here, we're going to show the data that is going to be just like wind. Then inside here, we can display by using a text. So this one is going to be a row in order to create that. Now we can space it a little bit by using 8 or 4 dp. Then we are going to display here by using the wind speed, and this one is going to be kilometer per hour, and we can incorporate also with the wind direction. Then here we're going to use headline medium, and here we can set the max line to be 1, and if everything is going to overflow, then we can use ellipses in order to show that particular wind speed. Or we can do something here instead of using this. Okay, let's use a basic marquee. So this one here is going to ensure that we have only one line, and if the text is going to be bigger, then it's going to create like an animation of movement that is going to show the whole information if we have a lot of information about that particular wind. So I think here we have the information about our card. Okay, let's copy this. So we have our first item. Let's add here a spacer, and that is going to be a height of 80 dp. Now the next case here is we want to show the sunset and also the UV index. So here we can create a row in order to display those two items side by side. So by using a row here, let's modify it a little bit. So we can use fill max width here, and let's pass in here the horizontal arrangement. And we want to arrange by using space between. So space between is going to push everything to the end of these items. And we have already created a sunset weather item, so we can just call it here directly. Let's give it a weather information, and now we can just call here it and pass in here. Now the UV index, we have already created this from our previous sections. Now let's pass in here the weather information, and we can give it again. Now that is pretty straightforward. Let's copy this, press Ctrl C. Now we have our row. Let's go below this and give it here a spacer of 80 dp. Okay, so I think everything here is looking perfectly. So the next case inside here, lazy column. Okay, let's collapse this item. I want to create again the line graph here so that we can show it. So we can create another item. Okay, we can check if this is going to be nullable, and here we can change our reference to daily weather information. So that is going to be our data point. Let's use the X value mapper, and here we can call it dot time, and we want to call here tech2. So basically we are going to show the X values. So those values about the Monday, Tuesday, Wednesday, we want only to show two values. So for example, Monday is going to be MON. So that is going to be the case. Now for Y values, so we can use here the temperature max. Okay, so we are just going with the maximum temperature here. We can convert this to float to make it. Okay, another case, let's give it a modifier. First, we can fill the max width, and the height here, we're going to give it 300 dp. So temperature over days to give it that case. So I think here our daily screen is actually completed. So everything here is looking perfectly. So the next case is just to test here our daily screen. So one thing before we proceed here, we can go inside our modules. Let's go inside our modules here. So we have our forecast view model. So the next case is we want to also provide the view model for which we have created here. That is just the daily view model, semicolons. Okay, so now here we have the reference for our daily view model. So I think we can use it. Okay, so I think everything here we have completed. One thing which I want to do is to add a navigation because we have only 2 or 3 screens here. So basically we're going to create our screens to be by using a simple navigation that we are going to create ourselves. But if you have a complex application, you can consider using a library for navigation. But for a case, we're just going to create a simple way which we can use this. So let's create here another package. Let's call this navigation. So you can use the navigation library from Android directly. That is going to be easier. So let's call this navigation. Okay, so inside here, I'm going to create a composable. And this one, you can use different types of navigations. And we want to call here the navigation type so that we can know, hey, okay, now we are navigating like this. Another case is I want to get the navigation item content. So I'm going to give this. So here we can pass in the image vector if we're using here, for example. Okay, so one thing is I'm going to create a simple way which we can use for our navigation. I want to get first state. So to get the selected index, that is going to be the tab. Selected index, that is going to be for our index. Okay, so here we can call remember savable. So remember savable in case of Android, this one is going to save it if we have orientation changes. So we can use a mutable int state of. By default, we're going to have 0. Okay, so the next case is we want to get the navigation content list. So we can call this navigation content list. So this one is going to be the list if we have 10s or 5 items. So for a case, we're just going to have 2. So let's create here our navigation item content. Okay, so here we can use that range to say this is going to be for daily. So we can just call this forecast, no problem. Or you can call it daily, whatever you wish. Okay, so inside here, you can use now the different types of navigation that you're going to have if you're going to use a navigation library. But for a case, we're just going to create our own navigation. So, okay, so we don't want this to be, so we can make it a private variable here. Okay, so this nav content here is going to contain different parameters here. For example, the navigation type on tab press. So the tab that is going to be placed here is going to give us an int. Okay, the next case, we can pass in here the navigation content. Okay, no problem. Another case is to get the current tab that is going to be selected in case when we are going to be using tabs. So if we are inside the font, so we can get the tabs. Okay, now I'm going to use here a box in order to contain everything. So let's pass in here a modifier. Okay, so inside here, we're going to, you can feel free how to customize and how to display your items. So from my case, I'm going to create here a column in order to show the items here. And we can fill first the max size of this particular screen. Then we can give it, the background. Okay, so inside here, I'm going to use different ways of displaying our items depending on the navigation type. We can use here an if statement. So we can check first if the navigation type is going to have the navigation bottom. So we can call here, for example, bottom navigation. Then directly here, we can show our bottom navigation. So here you can utilize your navigation scheme here. So we can call here our current tab. So we're going to check if this is going to be the index of 0. So we want to show here the home screen. So for our home screen, we can give it the navigation type. So if this is going to be equal to 1, basically now we are inside our daily screen. So we can call here our daily screen. So that is it. So we have here our home screen and also our daily screen that is going to take up the whole space. And else if the navigation type is going to be bigger, so basically we have a bigger screen, then basically here we can show a different types of view. So let's create here a row. So we're going to display side by side. So basically we can just copy here, for example, our home screen, but we're going to differentiate this by something. So for here, we can change our modifier. Let's give it a weight of 1F. Okay, so this one is going to give it equal amount of space depending on the second item. Now for the second item here, let's create here a spacer first. We want to differentiate this, and we can use 32 dp to display this. And because we know that we have a bigger screen, so 32 is going to be enough. And here basically we can give it similarly. Let's pass in here the modifier. And here we want to give it a weight also of 1F for our daily screen. So now here we have everything looking perfectly. Now, one thing which I want to add here is we have our column. Okay, so the next case here is I want to display a bottom navigation in case if we are having a smaller screen for this case in order to navigate between different screens. So for here, let's create another composable. So we can check if this is going to be selected. So we can call here our current tab if this is going to be equal to the index. So we can know, hey, we have selected. And the on click here, now we can invoke the on tab press and actually change here the index. So we can call here the index that is going to be the index of the item that is going to be actually placed. And another item here is to change the icon. Okay, so for our icon, we can create here an icon, pass in the image vector, and here we can use the navigation content item, and we can call here our item and call the content description. For content description, we can use navigation bar item and use the text. Okay, so I think this one is going to be enough for our case. So let's go inside here and below our row. So we know that, hey, we are inside here, the navigation item. So here, let's create animated visibility. So the animated visibility, we can check if our item is actually visible by using a simple way. So we can check here our navigation type. If this is going to be equal to the navigation type, that is bottom navigation. So I can say, hey, okay, we are inside this. So let's create our forecast bottom navigation bar. So let's create our current tab. That is going to be the state for our current tab. On tab press, we can pass in here the reference directly, the navigation bar item list. So we can call here navigation content list. And let's give the modifier. And we want to fill the max width. Sorry, not fill max size. So fill max width. Okay, so basically now we can go below here and call here our forecast navigation content. So let's pass in here our current tab. That is going to be the selected index. And lastly, we can give it the modifier directly. Okay, so now let's go inside here our app. Okay, so inside here we used our home screen directly. So what we're going to need here is to get this function. Let's press Ctrl X. Then we are going to delete it directly. So for here, we can call now our forecast navigation. So here we can pass in that function, get navigation type. Okay, so now here we have called our forecast navigation. Let's try here to run our application and see. Okay, so you can see here our app is now launched successfully, and you can see we have here our item. So because it has seen that we have a bigger screen that is going to display it. And also here we have our daily weather item. So You can see, for example, here we have our daily. Let's try to click here. You can see the data is changing. So I think everything here is looking perfectly. Okay, but one thing here which I have currently, I'm using a dark theme, but now it's just displaying here the normal theme. So we want also to be able to change different screens depending on the system is going to be in dark theme or not, so that we can enforce that also. So we can try to do this easily. Let's just go inside here, Android Studio, and do something else. So by default here, we have just a normal theme that we're using here, material theme. So we can create our custom theme in order to match that. So for this case, we have to provide different colors. So you can go directly here to this material theme foundation, and you can see we have this material theme builder. You can try just to Google it, a material theme builder, in order to go to this material theme builder here, which you can use to create different types of colors. So you can see here, it's going to give you different types of colors that you're going to require. So for a case, we're going to select this one, which is going to use that source color here. And here you can see it's going to give you different shades. So here we have high contrast. For example, high contrast is going to be like this one here. So you can make this one to stay true to that. So I think everything is going to look perfectly. And here it's going to give you a peek of how things are going to look. You can look at this. So I'm not good at colors. Another case, you can pick fonts. So you can change here different fonts if you want and other things. So for a case, we're just going to use the system defaults. And here now you can export it after you click finish. So you can see here down below, we have the export button. Now you can select different types of exports. So for example, for Android views, that is just XML, or you can use Jetpack Compose, Flutter, Web, and also material theme in terms of JSON. So for a case, we're just going to select Jetpack Compose and download this. Now, after the download complete, you can unpack that, and then you can proceed to copy the colors and themes and other things and use it inside your application. So let's go back inside Android Studio here. And then we are going to pack this. Okay, so inside here, our UI, we're going to create another package for a case. Let's press Command N. Let's create a new package and let's call this theme. Okay, so after you unpack that thing which you have downloaded through that material theme builder, you can paste in here the colors because it's going to have colors, themes, and also typography. So for a case, I'm going to create here a new Kotlin class, and I'm going just to call this colors. Okay, so I'm going to paste just the color values which you're going to have. So you can see we have all of these colors. Now the next case is we can create now our theme. Let's create another file and we can call this type. Okay, similarly, you can just copy that data directly here. If you want to customize your type, now you can do in this file here. And for a case, we're just going to create this app typography. So you can customize here by passing different things. So you can see display large and other things. If you want to customize the typography and if you know what you are doing, then you can just customize it here. Okay, so the next case here is to deal with our actual theme here. So I'm just going to paste here all the data that is going to be downloaded from that particular file. So this data here contains a lot of information. So you can see we have the light color scheme, we have the dark color scheme, we have the highest contrast light color scheme and other things. Okay, so now here we have our themes. So you can see we have everything. So here we have high contrast. And if you copy it directly here, you can see that this one is the data. You can see we are going to have these app themes. So just copy these items here. That is just the app theme that is directly going to be used for Android. And that is just going to use a dynamic color scheme. So for a case, we are going to create another case. Let's call here expect. Okay, so we are going to make this function to be implemented differently because we want to make the implementation for Android to use that color scheme that is going to be a dynamic system wallpaper in order to adapt to its color schemes here. So for example here, let's call the dark theme. Okay, so the content of this one is going to be a Lambda function. Okay, so we expect this to be implemented differently from different applications. Let's press Alt Insert and call add missing declarations. So we want to add for desktop, for Android, and also for native. Let's click OK here. Then these are going to be the files that are going to be generated. Okay, so now I think let's start with Android first. Okay, so here we have for Android, and if you cannot locate this theme.android, you can directly go to the modules here. Let's collapse this. Let's go to our Android modules. Let's go to our UI, and directly you can see that we have the theme inside here, theme.android. Okay, so inside here, I'm going to add this data so you can paste that information. So we want to use the color scheme here so we can check for the dynamic color scheme. And the dynamic color is going to be available on Android 12 plus. So if you have something less than that, so we can just get that dynamic color scheme and pass it here inside our material theme. Okay, so another case is I want to change inside our common source set. Let's go directly inside here, our common. Let's go to our, and we want to add two parameters here is to check first if it's going to be also it's going to be the Boolean. So we can make changes inside here. So for example, you have here our theme. Let's go directly to our Android package here. Let's go to our main activity. And you can see we have to pass in here the things. So here, for example, we can check dynamic color. We can make it to be true. And also the dark theme. We can check if we are going to have this. So we can pass in is system in dark theme. So basically in terms of Android, we can use these things here to check it. Okay, so still it's going to generate this in a different location. So I think let's just, okay, let's deal with first the native one. Let's go to native. And if you cannot locate this, you can just go directly here inside our native. You can see we have our UI, and inside here we have theme.native. Okay, so from here we can just directly call our material theme. And for color scheme, we can check if it's going to be in dark theme. And directly, let's go for iOS. We can go inside here, our main view controller. And here we can check if this is going to be inside a. And we can use similarly is a system in dark theme that is going to give us the same option here. Okay, so I want to copy this, which we are going to use it. So let's just copy this, Command C. Okay, so for our desktop, that is going to be placed in a different position. Let's just go directly here. Okay, so we want to make this. So if you have here this package like this one here, you can just use it, or we can just copy this package. Let's press Command C and copy it. Let's go inside here and paste it. Okay, let's call it UI and add it. Okay, and for a case we want to change this, so you can just click here and go to refactor. Let's go to refactor and call rename. Instead of theme.native, let's call this desktop. So everything is looking similar for here for our desktop and native. Let's go to our main view controller here. So dark theme, you can check is system dark theme similarly. And lastly, dynamic color is we can set it back to false. Okay, so now we have set here our theme directly. So we can go back to our app and see how we can use it. Okay, so now here we can go directly to our app. We can press Command E or Control E to go to this. Okay, so now here we have two parameters. So instead of directly calling here the forecast screen, so here we are going to use our app theme. Let's call here app theme. That is the custom theme which we have created. Now we have to pass in the parameter for the dark theme. And for the dark theme here, we can just call dark theme, this one. And also we can check for dynamic color, and directly we can call dynamic color. So as easy as that, we are going to get here our dark theme inside our applications.
Okay, so now everything here is looking perfectly and we can try now to run our application. So one thing which we can try and do here, I'm going to run on all platforms. So the first platform I'm going to run here is Android. Let's just click run here. Then Gradle is going to build for this. Again, I'm going to select for iOS. Let's try to run it again. Okay, so when we try to run here applications, you can see for iOS and also for Android, we don't get anything. And this is happening because we have not selected the location that is available inside our database. So it's just returning here a null value. So you can see, please select a location to get started. So this is not displayed here. So we have to deal with this. And here, basically what we can try to do is to add another inside our home screen. Let's directly go to our home screen. I think we have to change here. So here we're going to show our focused screen if we have the location that is selected. And if not, we are going to show please select a location to get started. Now, for our case here, we can easily try to show also here inside our animated visibility directly to show the user that, hey, you have to select something first in order to get started. Is location selected. So if this one is going to be, for example, the location is not selected, so we can negate this because this one is going to return false. So we want also to show the search location, which is here. That is the search location content to be visible if the actually the location is not selected, so that the user can easily select directly from this case here. So for that case, let's try to rerun again. So we can rerun in Android, and let's stop and rerun here for iOS. Okay, so for iOS here, it's showing, and now we can search here for any country. Let's try here Finland. For Android, you can see here it's looking perfectly. Let's click select here. Okay, so we have saved here our location. We can click this back. So this one is going to navigate us back. And here you can see we have our data. Okay, so here also in our iOS, we have created. You can see we can select here location in order to get started. Okay, so we want to search for a country here. So let's search, for example, here Dubai. Okay, so we have searched here for Dubai. We can go back. You can see literally right now we have here our data and everything is looking perfectly. Okay, so one thing which I'm seeing here is that our data is actually not visible. So you can see we don't have here our floating action button that we can use to navigate. Sorry, not our floating action, but our bottom bar. So we don't have here our bottom bar in order to navigate, and also here it's disappearing. Okay, let's also try in case of our desktop. So we can try and rerun again. Here inside our desktop, you can see everything is looking perfectly, and it is displaying 2 items for once. So you can see, because we said if we have a bigger screen, you can just show them side by side here. And if not, then you can just leave it as how it is. So here we have our daily, and our daily is displaying perfectly. When we try here to change, you can see everything is looking perfectly. Now let's try here to expand, and also whenever we expand, everything is looking neatly organized. So here we have the days, and here we have our graph. This one is for daily. You can see we took Sunday, Monday, Tuesday, Wednesday until Saturday. So everything is looking perfectly. And here we can try to see, you can see the temperatures are going to be changing, and these are going to be okay, temperatures. And here you can try to change a particular city. Let's try and look for which country here. Okay, let's search for Dubai, for example. Okay, so you can see this is the temperature. It's changing here and here also because we used the same state to observe. Okay, so what we have to fix here is, for example, you can see inside our emulator, we don't see here our data. So we can try to fix this. Okay, so the issue here, what is happening is, let's go inside here. So we can go directly inside our forecast navigation. So we can go inside our forecast nav content. And directly here, whenever we are going to show, if the navigation type is going to be, for example, inside here, the bottom bar navigation, what we want to do is to pass in here the modifier in order to make this to be in a certain position. So for example, here you can see we are using a modifier. Let's just copy this. So we can copy this modifier and give it a weight of 1F so that we can do this here. So let's paste it here, modifier of weight 1F, and similarly here, and give the weight of 1F. So this one is going to help us fix the issue because it's going to make everything to occupy the space, to leave the space for others. Because here you can see we're using a column and the content here can be bigger than the view itself. So for this case, this bottom bar navigation is going to be pushed outside of the view. So instead of doing that, we can try to use here a weight of 1F so that we can accommodate the space for this. So this one is going to be laid first. Then after that, the home screen or the diary screen is going to look up for the remaining space in order to display itself. So it's going to calculate the positions and other things depending after creating this one here. Okay, so for this case, let's try to run for Android and also let's try to rerun for iOS. Okay, so for the case for Android here, you can see everything is looking perfectly. Right now, our data is displaying. So when you click here, you can see also that we can have the bottom bar navigation displayed here. And because we used that weight 1F, so it's displaying. Okay, so you can see here for iOS also, it's looking perfectly. That we have the bottom bar navigation. So now we can use this to navigate between here. You can see we have here our daily screen. And here we have our home screen also. We can try to navigate and look for different places here. Okay, so here we have all of our data and everything is looking perfectly. So we have here a platform for Android, and here you can see we have the platform for iOS, and also here we have the platform for our desktop environment. So everything is looking perfectly. So guys, if you find this video helpful, please don't forget to provide a like, subscribe, and share this video. And it takes a lot of effort to create such tutorials. So don't forget, let me know in the comment section what you think and also what should I cover next. So until next time, see you in the next video. Bye bye for now.